Right. Okay, slideshow. Yeah, from there. Right. Okay. So we are starting with networking. Um, I don't know if you'll be able to recall what we did last week. Will you be able to do kind of a recap or to tell me what you remember from last week's section?
Yeah, that's fine.
Yeah.
So last week we started with basically learning about uh, regions, availability zones, data centers, and then we went on to how we can the reason why we choose a particular data set availability zones, which we talked about latency and maybe local laws. Um, yeah. And then we connected to a CLI as well.
All right.
Yeah, interface.
All right. All right. Thank you. Yeah. So, is there any other person? Gregory, do you want to add something? All right. I'm sure he's not closer to his device. Okay. So, yeah, last week oh, Gregory, can you hear me now? We can hear you if you can't hear me. So, last week we talk about data center, we talk about availability zones, we talk about region, we look at what will institute us to choose a region. We also look at how we can build a high architecture availability using multi-AZs and all of that. Now, today we are going to look at networking one. So networking is very important in the extent that all those resources you've been using so far, they are deployed, most of them, majority of them are deployed in the networking space. So today we are going to look at what are some of the things that they do in the cloud or the networking concepts in the cloud. Now, this is networking, but this is with respect to cloud. So if you have networking basics or you have a networking idea, you recall that whatever that we are going to do here is a transition of whatever that was done on the on-prem. This is what we are recalling here. So we'll do networking two, which will take us deeper into networking on AWS. But at the moment, this is networking one. Now, this is the overview of today's program. We'll start off with some business requests. Hold on, just give me a second. So we'll start off with some business requests. We'll look at what's our IP addressing. Then we'll dive on deeper to VPC, that is Amazon Virtual Private Cloud. We'll look at its fundamentals. We'll look at things associated to VPC, such as the traffic that is flowing through VPC. Then we'll present solutions to this business request right here. We'll do some capstone checking. Yeah, we'll try to kind of do some projects to mimic what we have learned in class. Then we'll go over some knowledge checks. So today we have a network engineer asking us a question. And what is their question? They are saying that how can we make sure that our network has enough IP address to support our workload? Well, we don't know now. The second question is saying, how do we build dynamic and secure network infrastructure in our Amazon Web Services account? We still don't know, so we are leaving that one to now. How can we filter inbound and outbound traffic to protect our resources? We don't know this one too. So by the end of this session, we should be able to answer all of these questions without any hesitation. Now, the first thing we will look at is IP addressing. Now, to make this simple for you, there are two types of IP addressing. There is an IP address called IPv4, and then there is an IP address called IPv6. Now, at the moment, a lot of companies are using what we call the IPv4. Okay. Now, this is an example of an IPv4, and this is an example of an IPv6. Now, somebody will say, that, okay, why do we have two IP addresses? Yes, we have two IP addresses because in the olden days, we were using what we call IPv4, this one. Now, the problem of IPv4 is that it is made up of 32 bits. Now, when we say 32 bits, it is written in this manner. So it could be 0.0.0.0. Okay. Now, slash whatever number that they want to use. So this 0 here can go up to 8 bits. This 0 here can go up to 8 bits. This 0 here can go up to 8 bits. This one here is also up to 8 bits. So 8 plus 8 giving you 16. 8 plus 8 giving you 16. Adding 16 plus 16 should yield a total of 32 bits addresses. So you'll be hearing people saying, IPv4 is 32-bit address. Yeah, this is what they mean. Because it's made up of each and every period is made up of 8 bits. So if you add all of them together, they are made up of what? 32-bit addresses. Any question? Is there any question on this before I go on? Now, I want to teach you something simple. I don't want to go deeper into networking because this is the networking basics. Now, if you see, because each and every number you see is made up of 8 bits, just like this one. So look, before the dots, this number, the 172 is made up of 8 bits. The 31 is also made up of 8 bits. The 2 here is also made up of 8 bits. And the 15 is also made up of 8 bits. So mostly, if you see the IP address and they are writing, they write number slash something, either slash 32 or slash 8 slash 16. You'll be seeing them a lot of time. Okay, today we are going to understand why do they write that number? Why do they use that figure? Okay. Now, because they are made up of that 32, if you see a number that starts in this manner, okay, any number that starts with, let's say, 192.2.4, okay, 1, 2, and say .7/8. Now, /8 here, what they are trying to tell you is that the first bit, okay, the bit which is before the dots. So any number that is standing alone is a number on its own. So the 172 is a number on its own. The 31 is a number on its own. The 2 is a number on its own. So the 192 also comes before the dots. The 192 is all classified into 1 bit number, which is what we call the 8 bits. So all 192 is made up of 8 bits. After the point, even if it's a single number, it is still made up of 8 bits. So if you see /8 here, what the system is telling you that, hey, I've blocked this one. This one is now fixed. You can't change it. Why can't you change it? Because we are using this number here. You see that they will write the number and do /8. This one cannot change. Now, most of you might have not been paying attention, but when you try to do it to your IP, why do you think they make it /32? So let me rub this. They make it /32 right here. You will see the number 32. Why do you think they make it 32? The system is trying to tell you that it should be the exact IP address. Nothing should change because we have blocked all of them. 8 is block, another 8 is block, another 8 is block, another 8 is block. Now on AWS, we allow up to /16, which will give you 65,533 or 30 something IP addresses, if I'm correct. Okay. So on AWS, what AWS says is that, look, all these addresses will give you 4 point something million. Okay. 4 point something million. Sorry, billion, not million. 4 point something billion. What AWS is saying is that, hey, we are not going to give you all the 4 point something billion per one VPC. So we will give you each and every VPC. We will block the first bit and we will allow you to use only /16. So you see, when we create VPC, we usually do /16, which we will be doing today. We will practicalize that for you to understand what we are talking about. So from this context, because IPv4 is made up of 4 point something billion, now the number of devices and people, even the world population, is over. Hold on, let me admit someone. The world population is over 8 point something billion at the moment. So even think of it. Okay, what if each and every one of us is using one addresses? Then we can use 4 point something million address. Okay. Now we are talking about internet routable addresses or IPs that could be internet reachable, not your private home, not your private addresses. So these addresses we are talking about, the maxing, is the internet routable ones. Now let's do away with these. Now, the network, the one that mostly they block, when you see the block one, it is mostly called the network. So look here. You see, they are pointing this one to you that this side, hold on. I don't know what I thought my pen was on. All right, so they are pointing this one to you that this one is the what? Is the network. And this one is the what? Is the host. Yes, depending on what we will block. If we give it /8, it means that now from here up to here is the network. If we give it /1616, then it means that from here up to here, these two is the what? Is the network. And this last two is the host. The host is the devices that are going to use those IP addresses. Now, no need to have even higher level overview of it. Okay, but just understand for me that there are two types of IP addresses available on AWS or even worldwide, which is what we call IPv4 and IPv6. Now, why do they bring IPv6? IPv4 is made up of what? 32 bits. So why do you think they brought IPv6? Now, IPv6 is a larger number. It is made up of hexadecimals. Okay, so this is how a typical IPv6 address looks like. Now, it is made up of numbers, made with some alphabet and all those things. Some of you might be seeing them. You just didn't know what they were. Yeah, they were IPv6. Now somebody will ask, okay, why wouldn't they throw away IPv4 and use only IPv6? It is not possible. Why? Because had it been I don't understand English, I will not be able to communicate with you. Now, some of the servers are using IPv4 for communication. They are not using IPv6. So if you create a server and you use only IPv6, then other people will not be able to communicate with you because it's a language barrier. Just like, if I don't understand English, I'll not be able to talk to you. That is the same thing that is happening in the text piece. If you use only IPv6, they can't talk to IPv4 directly. So you need to build something called dual stack. Okay? You build what we call dual stack. Dual stack is a stack that allow both IPv4, a server to have both IPv4 and IPv6. Okay, so understand IPv6 to be a bigger version. Now, IPv6 can give you up to 340 trillion. You can see it right here. 340 what? Trillion addresses compared to IPv6, which is 400 and 4 point something billion addresses. Okay, this one is trillion. This one, even decades upon decade, a century will come, we will still not max it out. But still, people do not have all their servers running only on IPv6. So you can't only go full IPv6 unless the people that you are communicating with are also fully using IPv6. Is there any question?
Yes, sir.
Yeah.
Please, when you say an octet is blocked, let's say behind the number is 8,
Mhm.
are you saying that the network portion will remain unchanged forever. Is that is that a blocking means?
Yes. Yes. It means it's a fixed number. Okay. So once you see, let's say 192.20/10 dot, let's say 8/8. Once here is 8, it's telling you the first bit, the bit before the dot. This one has been blocked because that is the 8. Now this one, this 22 is 8. This 10-2 is 8. This one 2 is 8. So it is adding this that gives you the what? The 32. Now, if they write 8 here, it means they've blocked this one. They've blocked this one. This one cannot change. It is going to remain fixed. Now, if you see /16 here, you don't see 8, but you are seeing 16 here. It is telling you that they've blocked the first two, counting from your left. They've blocked the first two. So the 20 bit and the 192 bit has been blocked. Block means it is fixed, it is constant, there is nothing that is going to change it. So in AWS allow up to only /16. So that is why AWS give you the first 2 1 are blocked and they leave the last 2 1 for you. Now, even with the last 2 1, if you multiply, you get 65,530 something IP addresses. Okay, just these two block these 2 bits when they are open. So when we say block, that is what we are talking about. They are fixed, okay, and they do not change. Do not worry, we'll try to practicalize this and then you understand it from that context. Is there any other question I need to add again? Now, what you need to know is that every IP must, I'll not put it that way. Now, every server needs an IP. Just like every person in the UK needs identification card. You need something that if the police sees you, they'll be able to know, oh, this is Mr. Arthur. This is Gregory. This is Olawale. Okay. So these things are identification. The same thing is what happens in the cloud or in the tech space. Now, IPs are also used to identify devices on a network. Any question? Any question? Now, there is something called CIDR or classless interdomain routing. When we create a VPC, we need to specify how bigger we want the VPC to be. Okay, you are going to buy a land. When you go to the estate developer, they will ask you, okay, what is the land size that you want? Do you want 2 plots of land, 3 plots of land? Now, in this context, when we are defining how bigger the VPC should be on AWS, we use what we call the CIDR block. So if you look here, they have given you /16. What is that telling you? It means which and which one is blocked. Help me here. They've given you /16. This is an IP address, and they've given you /16.
First 2 bits,
10 and 22.
are blocked.
All right, 10 and 22 are blocked. Okay, it means this 0 and that 0 is going to iterate itself to reach the maximum that they are looking for. Had it been, it was /24, what does it mean? Had it been this side is /24, okay? What does it mean?
An extra 0, so
from the left has been also blocked. So it means they've made this one fixed. Okay. And only this one is what is going to change. So simple as that. Okay. All right. Now, in AWS allow you to use up to /16 as the bigger network. Now, somebody will say, okay, why is it that if they increase the number after the slash, then the IP is becoming smaller? That is because the bigger the number here, the more bits they have blocked. So check it very well. The bigger the number here, if here is 24, it means they've blocked 3 bits. If here is 8, it means they've blocked 1 bit. So the bigger the number, the more bits they have blocked. So look here. You see the smaller bit is yielding 65,536 IP addresses. If you do it /17, you are also going to get 32,768 IP addresses. If you do it /18, this is what you are getting. /19, this is what you are getting. /20, this is what you are getting. Now, AWS allow a smaller network only up to /28. You can't go beyond 28. You can't block more than 28. And with 28, it gives you only 16 IP addresses. But if you do it /16, it gives you 65,536 IP addresses. So this is how bigger you can go in AWS. This is how smaller you can go in AWS. Any question? Any question? All right. So let's look at, we've understand IP addresses, that there is IPv4, there's IPv6. Now let's go through how we can build a dynamic and secure network infrastructure on AWS. Now we are going to look at a concept called VPC. First of all, we will look at the VPC itself and look at its subordinates like subnet, internet gateway, route table, NAT gateway, elastic interface, and we will look at elastic IP addresses. Okay. Now, what is a VPC? You know, the way we put up buildings, we hook it up with networking device. We rack the place, we kind of network the whole building so that wherever you are. Now, if you go to the mall, if you go to this restaurant, you see that there is network all over where you can just connect your phone and use. That is the same thing that happens in the cloud. AWS know that, hey, people will come into the cloud. Even though they were using network on premises, when they come into the cloud, how do we give them network? So AWS sat down and be like, okay, we will create a concept which is going to mimic the same thing they were doing in the cloud. So when you hear this word logical, logical means it is not physical, but it is working just like physical thing. Okay. So they created something called virtual private cloud. Virtual private cloud in the sense that it allows you to control your network in the cloud. So you can use VPC to provision a portion, to logically provision a portion. Okay, as I'm saying, we are using logically because it's not physical. Okay, you isolate a portion of the cloud. Okay, this is the part I want to protect. This is where I want to use as my own. It's just like going to a estate developer and be like, okay, look, give me this land size. This is where I want to build my house. So whether you want to build a gate, whether you want to buy a dog, whether you want to deploy security men, AWS does not care. Okay, we've given you the land. Whatever you want to do with the land is for you. So if you protect the land well, thieves don't come in, it's for you. If you don't protect the land well, thieves come in, it's for you. That is what VPC is. Now, VPC allows us to what? To deploy resources in it because it is mimicking the real life environment where we set, like, you know, the more that we go, that we connect to what network. So we are able to use VPC to control access to our resources. Now, first of all, know that when you create a VPC, it is a regional bound. Regional bound in a way that VPC cannot span outside a region. VPC lives within a particular region. They do not go outside the region. So VPC 1 will stay in one region. VPC 2 can be in that same region. Now, multiple VPCs can be in the same region, but one VPC cannot span outside the region. I don't know if this is clear. Is there any question? Now, when you were creating the resources, you were provisioning your server and those things. The reason why you didn't create VPC is because you already had a custom VPC created. Okay. Now let's go and look at our account and see if indeed we have a default VPC created. Now, so I'm going to say VPC. Right. So I'm going to VPCs. And then how will I know if this one is a default VPC? Now scroll down till you see tenancy. Okay. Here, it's right here. You see, there is a tenancy here, and it's saying this one is what? It's a default VPC. So look, I'm going to create VPC. Now, don't worry about how I'm going to create this because I'm going to automatically create this one, and I'm going to say create a VPC because I want to create another one and show you how it works. Don't worry, we will custom create VPC. We'll create it from scratch. We'll do whatever we will have to do so you understand how it's done, okay? So we just want to create this and then mimic how the VPC is going to look like. So yeah, still we have another VPC, which is called Project VPC. Let's go and look at the tenancy to see if it also has yes. All right. Look here. You see, they are saying default VPC. The project VPC is saying, no, I am not default. Okay. Then the other one that was created earlier is saying, yes, it is what? It is a default VPC. So the reason why you do not see or you don't have to create a VPC when you are doing all of this is because AWS creates the VPC for you. But also, if you want to create the VPC, custom create the VPC, you can go ahead and create the VPC. Any question? All right. Any question? All right. All right. All right. All right. Okay. So let's go through our slides. All right. Then, okay, we have created a VPC. We need something to divide the VPC. Now, in the first place, before I'll even take you through these concepts, let me explain something for you. Let me say Microsoft. Let me pull this here. Right. Let me go with these. Right. Right. Okay. And so, all right. So now think of this, okay? There was a company called ABC. Now, this company ABC, they spotted an opportunity. What is the opportunity? There was a town here, okay? Now, with buildings very closer to each other. So, ABC spotted an opportunity. Then they were like, these buildings are too closer. Well, when they spotted this opportunity, unfortunately, then theft cases started happening at these premises. Now, it happened in building A, but because they are all on the same compound, the thieves are able to come to building B, attack building C, attack building D, attack building E. Why? Because there is no walls, nothing. So once they still here, they're able to jump off to this building, jump off to this building, jump off to this building, and steal the entire village. Now, company ABC said, wow, we've spotted an opportunity. What are we going to do? Let's get a land. All right. Now they've gotten their land and they said, okay, let's build a wall just like I have around the land so that in the first place, it will even protect the community. Okay. Now they got the wall. They have protected the community. They said, okay, let's get something like a main gate. Now they have this main gate that is protecting the community. Now, then company ABCD told these people living here that, hey, your place is prone to danger. So you know what? I've got a land for you. The land that I have, it is protected. You can come and buy the land and also build another wall yourself. Then these people living here became very happy. Why? Because they were suffering with theft cases. If it happens here, it affects the other person iteratively like that. Then they started buying the land. So A came to buy a land here, fence the land. Now B came to buy a land here, fence the land. C came to buy a land here, fence the land. So you see, now they have spotted an opportunity and everybody here came to buy land from ABC. Why? Because ABC land give you the ability to protect the land. It gives you the ability, unlike this place where they don't build wall. Now this place, there are major wall covering the city before even your building also has its own wall. Now, the advantage of ABC companies is that even if building A has a theft cases or a robbery case, the people that were able to penetrate to the building A, they are not able to go to what building B. Why? Because building B has different protective mechanism. They are not using the same thing like these people, where I can steal you and also be able to steal the other person. Now, this concept is what we are talking about, VPC. Formerly, AWS was just deploying resources to each and every one. So if one customer gets hacked, it affects the other customer. And the hack continue iteratively. So AWS thought of it. They were like, okay, let's build an environment that will protect one from the other. This environment was built. Now, in this case, we have take this environment or the community to be AWS itself. Now, the boxes or the land, take it to be VPC. Now, after you buy a land, you divide the land. So you will be like, okay, I want to use this side for a bedroom. I want to use this side for a park. I want to use this side for a washroom. Now, by doing that on AWS, we use what we call subnets. So we use subnets to divide the VPCs into smaller chunks. So had it been the way they would draw their line, they would be like, okay, there should be a line here. All right, there should be one line here. Maybe this side will be called room 1. Maybe this side will be called room 2. Maybe this side will be called room 3. That same thing, that same concept, that is the same thing that we are doing. Now, when we create a VPC on AWS, we need to divide it into smaller chunks. So to divide it into smaller chunks, we use what we call subnets. Any question? Any question?
So can we say the objective of VPC security is that a case?
Yes, networking itself is for security purposes. It is not iteratively to communicate with other people. No, it's to protect the environment. That is why they are telling you that it's an isolated. You heard the word. Isolate means to differentiate, okay, to give a clear differentiation. So yes, you are correct. Is there any other thing? Is there any other thing that you want to know? All right, so look at what is happening. This is the region we are talking about. This is the VPC. This is the bigger community that they purchase. Now, what's happened? They want to put up a building. Now, because they want to put up a building, they can't just put up the building anywhere. So they have to divide the land. Now, to divide the land, they have to use what we call subnet. So look at what they are doing. They are dividing this side and calling it private subnet. They've divided this side and call it what? Public subnet. They've divided this side and call it public subnet. They've divided this side and call it private subnet. Simple as that. Just like we did to our land. They're also doing the same thing to the VPC using what we call subnet. So the subnet is used to divide the what? The VPC. Now the subnet also has a CIDR because when you are dividing, look, even if I have a circle, okay, so let's take it like I have a circle. I'm sorry. If I have a circle and I want to divide the circle, I must be able to tell that, oh, okay, I'm dividing the circle 50-50. Or maybe I have another circle, but I'm dividing it what? 70-30. And remember that when I cut this side off and I'm coming to divide the remaining again, I can't come and cut this side again and add it to this A. Why? Because I've already differentiated the A already. So you can't cut this side again and add it to it. Now, in subnetting, you hear something like no overlapping, no over what? Overlapping. It simply means that what? You do not cut this portion and come and cut it again. So if you look here, CIDR block cannot what? Overlap. Yes, because when you cut this side, you don't have to come and cut that same again. Now we are going to practicalize this using the console again. It will add more understanding for you. Now, each subnet resides in an availability zone. So this is it. VPC is a regional something, very bigger man. He lives in a region. But if they want to divide the VPC, then they will have to use a subnet. A subnet is not a regional something. It only lives in an AZ. So if I want to get subnet 1, it means I'll have to choose a particular AZ that subnet will live in within the region. It cannot go outside the region because its mother, which is the VPC, is not an interregional bound. It is just a regional something. Okay. Any question? Anything again?
I've got a question.
Yeah, sure.
So, the VPC is the region, and then the subnets are domiciled in an availability zone.
Yeah, sure.
Say we have a region with about 3 availability zones. I'm just theoretically saying.
Yeah.
Then, and you are supposed to have subnets exceeding 3. How would that function? Can you have 2?
Let me understand your question. Hold on. Let me put up something so we can understand your question actually. Now, what you mean is we have 3 regions, right? So
We have a region with 3 availability zones in it.
oh, okay. So hold on. This is a region with 3 AZs.
Yes.
All right. So AZ1,
Thank you.
this is AZ2, this is AZ3. Yeah, what's your question? Go on again.
And your build is going to be 4 subnets, but this has only 3 AZs, and each subnet cannot be domiciled in one availability zone. How can that work?
It is not going to be possible. You can have 2 subnets living in the same region, but if the regions AZ are 3, you can add another AZ. So it means that maybe you have 2 AZs, you have 2 subnets in one AZ. That works.
Okay.
But then, had it been there is only 2 and you still want 3 and you want each and every one to be in another AZ, it's not going to be possible.
Okay. So
Yes.
meaning you can have 2 subnets in a particular AZ.
AZ.
All right.
Okay. Yeah. But even with that, the subnet should also not overlap. Overlap in the sense that you cut this side for AZ1. When you're coming to cut, you cannot come and cut that side again. So you have to
All right.
go on and cut another side. Yeah. So
All right. Thank
Yeah.
you.
you're welcome. All right. So an availability zone can contain multiple subnets. It's right here. So one AZ can contain multiple subnets. So when you create these AZs or subnets, there are 5 addresses that are reserved. Don't worry about those addresses. We will look at them later. Okay. AWS use them for a lot of things, so don't worry about that. Now, using subnets to divide your VPC. We've talked about this already. Okay. So we build a VPC as the bigger network, then we use the subnet to divide this VPC. We have already looked at this. Now look at what is happening. So they are using subnets to divide the bigger circle. So you see, this is subnet 1. They've cut one side of the circle. This is subnet 2. They've cut another side of the circle. This is subnet 3. They've cut another side of the circle. This is subnet 4. They've also cut another side of the circle. So this is just to tell you that, okay, it is the subnet, or it is the VPC, the bigger VPC that we are using the subnet to just divide. So how bigger you want your subnet to be is going to depend on what you see on this number here. Now, if you give it a bigger number, it will cut a bigger portion. If you give it a smaller number, it will cut a smaller portion. Any question? Any question? All right. So, yeah.
So how are that numbers determined? Like if I want a
we
certain...
determine the number through CIDR block. I told you that the CIDR is the overall, is the bigger network. We use CIDR to state that, okay, this is how big I want my network to be. Okay. So you determine that through the CIDR, which we will be looking at it
okay.
with a hands-on. Okay. All right. So there are things like, public subnet and private subnet. Why would they call a subnet public? Now, a subnet is called public if it has one thing. It has what? IGW, Internet Gateway. It's right here, Internet Gateway. Now, what is Internet Gateway? Internet Gateway, think of it like a router in your home. that allows other network outside to send you a message, and it is also able to take your message outside. That is the same thing that happens in the cloud. Okay. So there are people. So think of it when you come back to our architecture that we had here. Think of it this way, okay? That the IGW is more or less like, these people that are working here, okay? They are at this side, and then they are able to what? To allow people to come into the building and also go outside the building. Now, if this internet gateway is attached to any subnet, the subnet is a public what? Subnet. Please listen to me again and again. How will we know this is a private subnet? How will we know this is a public subnet? A public subnet is a subnet that allows servers to be reached outside the internet or over the internet. A private subnet is a subnet that does not allow anybody outside the network to reach the server within. So a public subnet is the one that has what? IGW attached to it. A private subnet is the one that does not. Now, we will also practicalize this one more time. I'm saying this one more time so you understand. We will practicalize this using the concept when we are building. Then there is also a route table. Yes, so we need to route because we are going to say, okay, route table is like giving a vivid direction. Okay, so look, even though you live in this building A, if somebody is coming to look for you and they don't know the way to get to your building, they will still struggle. So route table is like, okay, if you are looking for Penty who lives in the compound A, come to this side, pass this side, go and pass this side, come to this direction, come and pass here, and then pass here. So route table is like a roadmap. Okay, route table is like a roadmap. Okay, where should I pass? Pass here, pass there, you get there. Pass here, pass there, you get there. So we use route table to determine where the traffic should flow in and out of our VPC. Okay. All right. Then, yeah, we also have some IP addresses that are public and then some that are private. Now, if you hear that an IP address is public, it means that it can be reached over the internet. If you hear that an IP address is private, it means it cannot be reached over the internet. Okay, so think of it this way. You have a phone number. Now, this phone number cannot be called over the internet, or somebody cannot call you outside your home. Think of it like your intercom. Has anybody ever called your intercom? Maybe when they are outside your premises. No, they don't call your intercom. I don't know if maybe in UK they call intercoms, but in Ghana they don't call our intercoms. Okay, that is because the intercom is within a confined network. Now, if somebody is outside your network, then they call your phone. Why? Because your phone can be reached over the internet or over the network. Okay. Now, that is the same thing that is happening here. Private means it cannot go. Public means we can reach it. So, look at the example right here. This is a public subnet. What do they have? They have a route table that is saying, okay, if somebody want to go here, come and pass here. Go and pass where? Go and pass through the IGW and hit the internet. Simple as that. So, they will design this with time and other factors. Now, we've said a lot of things about internet gateway. What is internet gateway? Internet gateway permits communication between instances in your VPC and the internet. So it is what facilitates the communication between the internet and your resources. So it's the one standing right here. Okay. So it's the one that will say, okay, if somebody need an internet from this side, it is this man that will take them to the internet. If somebody too is coming in, it is this man that will bring them inside, because it is the one that is going over the internet and bringing the resources to the what is it called? The servers. Okay, the servers are just stuck there. They are seated somewhere. Just come. Okay. Yeah, tell me what you want. I'll give it to you. If you have it, I'll give it to you. If you don't have, I'll just throw you an error. That is what the servers are basically doing. Now, they provide target subnet. Don't worry about all these now. We will leave it later. Now, through hands-on, you understand this one later. Now, route table, I told you route tables are like road. Okay, they are like roadmap. So think of it. You are going to visit a friend. He gives you a map. That is route table. So route table is saying, okay, even though you know I'm in the public subnet, this is where you can pass and come to me. So we also need route table. Then private subnets. Well, we've looked at public subnet. What is a private subnet? So look here. If you look here, you see there is a traffic flowing from the public subnets to the what? To the internet gateway and then to the internet. But if you look at the private subnet, there is nothing flowing. There is no flow. So look here. It only ends here. It is not connected to the internet gateway. Once you connect this subnet to the internet gateway, you've invalidated the purpose of it being a private. Okay, so please take note that private subnets are standalone. They do not connect to the what is it called? To the internet gateway. Now, there is something very, very important called NAT gateway or NAT. Why is NAT very important? Now, look at it. NAT is very important in this concept that, look, you live in this environment. Your father is saying that, hey, I don't want my world to go out. So your father goes to hire a security personnel who will be here and taking care of the gate so that you don't go outside. Now, this security personnel is already outside. They are standing by the gate. They are outside. They are not within the house. They are outside. They have the opportunity to go to wherever your daddy doesn't want to go. So they can come and pass outside, go outside, and they can also come inside because they are not restricted by your daddy. Your daddy is just trying to restrict you. Now, in this concept, let's assume you inside. Let's say, Arthur, you are inside. You want to buy something outside here. Because your daddy does not allow you to go out, you need somebody that you can send, somebody that can go outside to go and buy the thing and bring it to you. But in this case, if you go and use NAT gateway will go and buy the thing for you. All right. By then, if they get here and somebody is saying, oh, okay, I'm also selling a product. Maybe it's a perfume. Can you take one of the perfume and go and show it to Arthur in A? It will tell it no. It will tell the person no. Why? Because it doesn't take information from outside and come and give it to you unless you have sent it. So we call it one-way communication. Somebody will say, okay, why won't we use NAT gateway? Why won't we use internet gateway? Because internet gateway is a two-way communication. The problem is that with internet gateway, if it goes outside and somebody gives it information to come and give it to you, it will bring it. So whether it is good or bad, it will bring it. But with NAT gateway, it is only one-way communication. If Arthur wants something outside, I'm going to get it. If somebody wants to get Arthur something, I'm not sending it. This is the difference between NAT and internet gateway. Any problem? Any question? Any addition? Is there anything you want me to add more to? All right. So we use NAT to give what? The private subnet internet, because these people, they do updates. Sometimes our servers, like databases, stuff, they want to do updates. But they can't go over the internet gateway because the internet gateway will allow bad things to come and hit them. Maybe it's your server, it's your database. You don't want people to hit it. And the internet gateway has allowed communication to hit it. And they've now kind of hack your database. You'll be pissed. So what do? You use NAT gateway. So what you tell NAT is that, hey, I know you are already living outside, like you are living in a public environment. Look at it. They are living in the public. And you tell the NAT that, hey, NAT, I know you are living here. This side, you are able to go outside. So what I want you to do is that maybe go and buy something for me. The NAT will go outside, fetch it nicely, come back to you, come through the NAT and come and give it to you. It will not go and pass anywhere. It will come back and give it to you. And it also make use of the what? Of the internet gateway. So without the internet gateway, the NAT too cannot go outside. The NAT is literally using the internet gateway to go outside. Okay, this person is saying they want this. Let me go and get it. Then they go and fetch it. They give it to the NAT. Then the NAT come and gives it to you. Just like I said, if somebody try giving you or giving the person something outside, the NAT blocks it because it is a one-way communication. So look at it. Use NAT to protect your private IP addresses. So you use NAT to protect this private IP addresses so that nobody even sees the IPs. Now, this one has its own IP, the NAT, it has its own IP. So if you want to go over the internet, it uses its IP. It doesn't use your IP. So your private IP that you have here, it is hidden. Nobody can see it. So even if you private subnet try to talk to outside servers, they see the NAT IP instead of your database IP. Any question? Any question? All right. So let's go on to connecting. Yeah, Gregory, you want to ask
I
a
was saying
question?
that so the NAT is typically for patches, updates, or some serious work other
Well,
than patches.
well, they are for one-way communication. So whatever you want your private subnet to have internet connected to NAT, simple as that. If you don't want them to have internet, no need to connect NAT. It's not by
All
force to connect a
right.
NAT.
All right. All right.
Okay. Yeah.
I've got one question.
Yeah, sure. Go on.
You said when you attach a internet gateway to a private subnet, it invalidates the privacy and becomes a public net. So
Yes.
in a subnet, can we have an entirely public subnet?
Yes. You mean in a VPC, right?
Yeah, in a VPC. Can we,
Yes.
instead of having
Yes.
private and subnet?
All the subnets can be public. Now, let me show you an example. You know, the default VPC that was created for us. Let's go through it. Now, let me delete the one that we created. I tried deleting it. I don't know why it didn't work. Let me delete it. So let me say delete, say enter. Right? Okay, good. Now it is deleted. So let's look at something. Now let's open it and then let's look here. I just want to show you something. This is about how many subnets. Look here, 7 subnets. Subnet 1, subnet 2, subnet 3, subnet 4, subnet 5, subnet 6, subnet 7. Now look at what is happening. They are all going through one route table and they are all being routed to the what? To the internet gateway. Look here. You see, this is the internet gateway. That is the name, IGW, internet gateway. That's the full meaning. So they are all using one road. That is what it's telling you. Now, had it been we want to make some private, we will just disconnect it from the internet gateway. That is all. We've made it private. So once we disconnect it, it is not going to get internet connection. Any problem? Any question? Any addition?
No, that's fine. Thank you.
All right. You're welcome. Right. So let's go on with this one. Well, I guess you've all understand NAT now. NAT gateway or NAT instances. Now, well, we've looked at connecting private subnets to the internet. Yeah, that is where we use the NAT. Okay, so if we want to connect private subnets to the internet, we are using the NAT. Especially if we want to make it one-way communication, we are using the NAT gateway. Now, there is something called Elastic Network Interface. Somebody will say, okay, what is Elastic Network Interface? Now, on your laptop, it has something called NIC, Network Address Card, Network Interface Card, okay? It's called NIC, Network Interface Card. That Network Interface Card, it is for that reason, that is why your laptop is able to connect to the internet. It is for that reason, that is why your laptop is able to connect to the Wi-Fi, to the fiber, to the broadbands. It is that thing that is embedded on your laptop that helps you to connect to it. Now, on AWS 2, we use one called Elastic Network Interface. Why is it Elastic Network Interface? Why is it elastic? Because you can associate it and deassociate it to another server. So we can add it to this server, deassociate it from this server, and then add it to this server. Simple as that. That is why it is elastic. It's not static. Okay. So it is what help us to communicate with these instances, or that is what give us the network to be able to communicate with the instances. Okay, so now you are seeing it here, can be moved. Oh, I don't want this. Hold on, I don't know what's happening. Right? Yeah, so can be moved across what resources in the same availability zone. Yeah, so had it been they are in the same AZ, this server and that server in the same AZ. You want to remove the elastic network interface from here and add it to this one. You can simply add it to. Somebody will say, okay, why do you need to remove this elastic network interface and add it to this? Now, think of it, the way your laptop can be connected to router, it can be connected to fiber, it can be connected to Wi-Fi at the same time. That is the same thing that we can do in the cloud. We can connect multiple network to one server. The whole idea is that when one network is down, maybe by AWS, another one is responding, even though it is virtual. Okay, so we can also do the same thing there. Okay, all right, and it is where our security group, our MAC address, okay, that is where they are all located, the ENI. It is just like your own. Your network interface has your MAC address. It has your what is it called? Your IP. That is where your IP is allocated. Yes, when you come to AWS 2, it is where all these ones are happening. So Elastic Network Interface is very powerful. Any question? Now, look at what is happening here. We call something elastic IP address. Now, whenever we start and stop a server, the address of the server change. Let's not theoreticalize this, okay? So let's do EC2. Let's try to practicalize this. Now, before that, is there any question? Right. So I'm going to create a server. I don't need a name. So I'm just going to say, anyway, what do I mean? I don't need a name. I think I even have a server running already. So let's go back here. Oh, I have a server running already. Okay. So let me get the server. Let me just remove the S. Now, those of you who might not know, if you create a server, you are trying to connect to the IPv4. So look here. What we've already looked at. You see, what is happening? Why is my pencil not working? What's happening? Let me refresh this. I don't know why my pencil is not working. Oh, all right. I think it's working now. Let me see. It's showing it's just not letting it right. Okay, let me do this. Let's see, all right. So look here. You see, this is what's happening. Yeah. Oh, I think it's white. Let me change the color to red. Look here, you see there is what? A public IPv4 right here. Okay. And then if you go here, you see a private IPv4 right here. Okay. Now all the IP addresses has been assigned to one server. If we want people to reach the server over the internet, we can't use the private IP. It will not work. The private IP is only used for internal communication. It's like your intercom. You use the intercom to communicate in the house. Maybe your mother is at the kitchen. You call them on the intercom. Hey, mommy, I want ice cream when you are coming to the hall. That is it. You can't use the intercom and call your mommy at workplace. Now, this is the same thing that is happening here. This IPv4 address, there is something unique about it. Okay. So let's look at that. Now, let's get to this server and then listen to what is showing. All right, so this is the address that is showing. Look at the IPv4. Look at it, it's right here. But let's get hold of the server. Let's stop the server and then start it again to see what will happen. Okay, we are stopping our server. So let's just refresh these to see what is going to happen. Okay. Did it really work? Oh, it's still running. I'm not sure it worked. Let's select the server and then we will say stop. Oh, stopping. It has now initiated it. All right, so you see it's in the stopping stage. Let's look at what is going to happen. You remember the IP, right? This particular IP. Let's look at something. Something unique is going to happen. So let's look at that. Now the server has stopped. So what am I going to do? The same server that was stopped, let's open it. You see the IPv4 is gone. Why is it gone? It was given to us by AWS. So AWS have taken it back. They are saying, okay, what have we done? We have put in the server off. So AWS is like, okay, if your server is off, give me my IP. AWS has taken the IP back. Now, if we start the server, AWS will give us IP again. Why? Because they are going to think that, hey, you need to communicate with the internet. So take an IP that you can use to communicate with the internet. But what happens if we don't want the IP to be changing? Because they are going to give us different IP when we start the server now. So let's try it and see. Let's say start. Now the start has been initiated. Let's wait for some time. It's going to populate here. Look at that. Another IP. Let's go and look at the first one that was given to us. Look at it. 54.14. Let's look at if it's the same thing. It is not the same thing. 54.84. Look at it. 54.145. Look here. 54.84. It is not the same thing. It has totally changed. What happens if we want single what? IP to be constant so that even if we start and stop our server, it will remain constant. Who can tell me what to do? Now, we need something we call elastic IP. It is right here. Arthur, you want to ask answer the question for me?
Yes, I think you need to reserve the IP.
All right. So how do we reserve the IP?
Maybe by using the dedicated instances.
I'm not so sure if you really know what dedicated instances does, but dedicated instances do not kind of what is it called? It does not reserve an IP. Now, to get a static IP, an IP that does not change, we use what we call elastic IP. It's right here.
Oh, okay.
It's right here. Yeah. So we are coming to get one IP address. I'm going to say allocate. Now and tell AWS to allocate it for me and say allocate. All right, there you go. Okay. So AWS has allocated an IP address for me. This is it, 3450 point something. Now I'm going to say associate an elastic IP address. It's going to ask me, what are you associating? What do you want to attach it to? I'm going to say instance. Okay. And say choose the server from here. Which one is running? I'm going to give it to this one. Railvine server. I'll give it to it. And say, do you want to also kind of give it a private IP? I'm going to say no, allow it to do its own thing and say associate. Now I've changed the IP from what they gave me to something static. So let's go back to the server. Now this is it. Let's go and look at, you remember this is what they gave it to us, right? Let's refresh it to see. It should change by now. You see, it has changed to our own 34.0. It has changed, right? Let's stop the server. So let's say stop instance and say yes, stop. Okay. And then let's give it some time to see if the instance stop. We'll start the instance again. We'll see if it's going to change the IP address. Now, the whole logic of this hands-on is that if you want to let your IP address be static, you use what we call elastic IP. You use elastic IP to allocate an IP to make it static. But if you use the public IP that is not elastic, it is just going to make the IP change whenever you start and you stop and start your server. Now the server has stopped, right? So Railvine, let me go and make hold of it and say start instance again, just like we did earlier on. Now let's visit the server again. Look at it. The address remains the same, even if you refresh it. It's still the same. It will never change. Even up to 10 years, it will not change. Why? Because we've given it an elastic IP. Any question?
So this elastic, we can dissociate it and then pass it to a different instance. Okay.
Yeah, it can be deassociated from this server. We'll add it to another instance as well.
Okay.
Okay. The elastic IP, do you have to pay a certain cost
Yes,
to
it is
keep
not
it running?
really. It is not really free. All the services that I'm running for you, they are not free. It is just that I have about $1,000-something in my account, so I don't really look at what I do. I practicalize it. Okay, so please, if you want to do whatever that I'm doing, make sure you have some credits, maybe some $100 credits. It is not something huge. Just get some $100 credit or something that just will enable you to just practicalize what we are doing. But basically what I'm doing are not free. Yeah, you can see this is my credits. So they are not free. Elastic IP they are charged. Okay. All right. Any question?
Yeah.
Yeah.
At the point when you were associating an elastic IP to the instance, there was an option that says to choose your own IP. Don't know if you recall, where you could.
Let's go back to elastic IP. It was telling us to choose our own IP.
Yeah, if you want to choose your own IP and which we left.
Let's go here. Did you see that?
No.
Yeah, I don't know if you are talking about the what is it called? The private one. So the private one, they will give you the opportunity to go ahead and provision your private. But when it comes to the IPv4, the public routable one, if you look at it, Amazon pool of IPv4 addresses, they pull it from their pool of IPv4 addresses for you. So you don't have control over it. So when you say allocate, then they will look into the pool and pick one for you, the one that is available.
Okay.
Yeah. All right. Okay. All right. So please take notes that these things are charged. I'm going to deassociate I'll say deassociate an elastic IP. So as simple as that, we can deassociate it. That is all. And when we deassociate it from the server will be giving another IP again, which is what dynamic, which will just be changing. So because we are taking the elastic one back from AWS. Okay. So simple as that. Please make sure that when you do that, you deassociate and you delete them. The other two, because I'm using them, that is why they are there. Okay. Right. I don't know why it's keeping forever to deassociate. Okay. Is there any other thing too that you want to know again? So this is elastic IP address. I don't think we will have to go to it. All right. Is there any other thing? Now there are some stuff that you should know. Okay. Look at it. Can be reassociated and what can direct new traffic immediately. Yes. So just like we did, we deassociated it. We can add it to the other server right there. Okay. So if it was a traffic we are expecting, we'll just deassociate it from here. We add it to this one. So somebody will say, what is the essence of this? Yes. Okay. Had it been you have one IP, people know and they are hitting that IP and your server is down, you can deassociate the IP, add it to another server that is working more, and then the people will be able to hit your server now. Okay. Now it supports the idea of what? Bring your own IP. Why? Because AWS is giving you the IP. So you can create a server and say, okay, I want to allocate my own IP, which you have given to me to the server. It's not AWS that will give you the IP. So it supports that idea. Okay. Now, by default, you can have up to 5 per region in your account. Each and every region, you can have up to 5 elastic IP. Currently, I have 3, so I just have 2 more. You can increase it using service quotas. Okay, you can use service quotas to increase it. But at the moment, just know that you have up to 5. Now, those of you that are planning to certify after this program or after this course, it might come in your exam. So please make sure that you are keeping it at the back of your mind. Now, what happens if we want to deploy across multiple availability zones? Well, we do them. So we create one VPC, and then we deploy in this AZ. We create subnets in this AZ, and then we deploy our resources. So if you want to have high availability, or we want to make these resources highly available, then yes, of course, we can create what subnet in each availability zone and deploy our resources to make it highly available. Any question? Any question?
Yeah.
All right. Yeah,
I think I found out where I lost my question. So the question was coming from bring your own IP address. From where are you going to bring your own IP address? Are you going to self-generate, or
no?
How is you going to get your own IP address?
Okay. Now, if I give you a car that, hey, okay, Mute, you said you need a car. Maybe you want a G-Wagon, but I don't have a G-Wagon. Maybe I have some Range Rover somewhere. I said, hey, take this Range Rover, okay? Now, if you are coming to my wedding, you can bring your own car, which was given to me by you. Now it's your own thing. You decide to do what to do with it. If you are coming to my wedding and you decide that, oh, I don't want to go with this car, I want to use another car, that is fine. But if you want to bring that same car, we will also allow you to bring. Now, when you demand for elastic IP, it is for you forever until you say, I want to release it. So once AWS give it to you, it has become your own. That is why they are saying the elastic IP address mimic the idea of bring your own address, because the address is now for you. So if you create another server, you can be like, okay, I don't want you to use a dynamic IP. Use this, my IP. Simple as that. Is this clear?
Okay, it's clear for now.
Yeah. So on-prem, I mean, bring your own IP address means you have a particular IP from a provider that they have allocated for you. But in this context, it is given to you by AWS, and AWS is saying, okay, you can use it wherever you want to. So just supporting the idea of bring your own address. Okay. Yeah. Right. So let's go on. Now we are going to look at how we can control traffic in a VPC. Okay. So after all of this, then we will go back and look at the hands-on very well. Now, network control list, something called network ACL, or you hear people call it NACL. Okay, so let's go back to our environments. I like using this so you understand. Okay, there are people that will protect the environment that the security people, the estate has created. Maybe they go for security men that are protecting the environment. Okay. I don't know what is happening to my mouse. Why is it going down by itself? All right. Oh, I think my hand was on it. So they are protecting the environment. Let me delete it. I think it's looking too wretched. Let me just go down and create more. Right. So let me see. All right. So look at what is happening. This is the environment. Now they have people protecting the environment. Okay. In this context, which is the VPC, in this context, or in AWS, we use what we call WAF, Web Application Firewall, not well-architected framework. We call it WAF, Web Application Firewall. We use it to protect the entire subnet, the entire VPC. Okay, what if I divide it? When I divide it into smaller chunks, who will protect the smaller places? Now, this place, the almighty place I have divided, will be protected by what we call the NACL, or the network ACL, the network access control list. Now, if I provision a server in here, which is EC2, then the EC2 will also be protected by what? SG, security group. So the VPC is protected by WAF, NACL protects the subnet, then the servers are protected by security group. Any question? So everybody and where they are protecting. This one is not protecting the other person. Now you have your domain. I also have my domain. Let me protect here. You protect here. Let's all do the same work, but we are doing different things. Any question? Any question? Now, when it comes to the issue of NACL, it works in a way that it doesn't make sense to me, but that is how it works. Okay. Now, we have something we call stateless. Stateless in the context that now whoever comes into the building, so think of it this way. There is one security man here. Whoever comes into the building, even if it's the building owner's mother, if they try going out, the person will call the owner and be like, boss, did you ask your mother to go outside? If boss say no, he will walk the mother back into the room. Now, the same thing, if you are coming inside the room too, he will ask you, hey, is your son saying come inside? If your son say no, he will walk the person back. So that is knuckle. Knuckle is just doing two-way communication. It checks both the traffic that is coming inside and the traffic that is going outside. You see, now if you see a typical knuckle, it mostly comes in this manner. You see rules that are made in this form. Now, same rules, one is deny, one is allow. Why? Why do you see it like that? Now, knuckle does evaluation starting with the lowest number. So it's right here. It evaluates rules starting with the lowest number. So if you look here, they have made an inbound rule. The inbound, the one that is coming into the subnet, and they are saying, okay, 100, which is smaller than 200. They are saying HTTP, TCP, and then what is the protocol TCP? What is the range? It is port 80. They are saying what? Allow. And the same rule has been made again. What? HTTPS. They have another rule, HTTPS, TCP 443, and they are saying allow. And then they have another rule saying all traffic. So all traffic, HTTP is part of all traffic. And they are saying all traffic should be denied. Look, and there is some star sign here. What does it mean? Now, star in tech means multiplication. Multiplication is bigger than any number in this world. Now, if you have 1,000, you are multiplying it, you are getting bigger number. But if you have 1,000, it's just there. It's just 1,000. So 100 is lighter, 200 is lighter than multiplication because you don't know even the number they are multiplying by. What if they are multiplying it by 500? Okay, maybe 500 times 2, which will be larger than 200. So this one, even though it's telling the traffic to be denied, the system is not going to look at the bigger number. It will only look at the smaller numbers. So if you look here, 100, which is saying allow, and if you look here, 200, which is saying allow, and they are telling you here that they start from the lowest number. So the lowest number is 100 and 200. So the traffic is going to allow to flow. Now, if you come to the outbound, the same rule has been made. They are saying, okay, any rule, okay, which type of rule? 100. Any rule which is TCP, port range, they specify the port range that they want. And they are saying which source from anywhere. Allow it. And they are also blocking all. They are denying all again. Somebody will say, okay, if you do it like this, then we will deny because in AWS, explicit deny always stops. Just put it at the back of your mind that whenever you deny something explicitly on AWS, it always stops the class. But in this context, when it comes to knuckle, it is not always the explicit deny. It is the lowest number. So AWS advised that you use, if you are defining knuckles, you use 100, 200, 300, 400, 500, 600, 700, 800. Yeah, that is the advice. But even if you use 1, 2, 3, 4, they will still work. But AWS is just looking for a way to evaluate the number. Any question? Any addition? Any question? Well, let's look at some default knuckles so we understand what we are doing. When we are done, we will also try to mimic our own thing, but let's look at knuckle at the moment. All right. So look here. Main network ACL. Let's open that. Now look here. All the 5 subnets are associated to it. You can see associated 7 subnets. They are all associated to it. Okay. Let's open it and let's see the rules. So let's open The inbound, look at the inbound. So look here, the same thing we saw on the slides. They are defining a traffic here. They are saying all traffic should be what? Should be allowed. It's right here. And they are saying all traffic, star all traffic again, should be denied. Why is the allow working? Because it is using the smallest number. Now let's go to the outbound again. The same thing. All traffic should be allowed. All traffic should be denied. So please and please, if you are making a knuckle rule, that is how you go about it. Okay. So please take notes that that is knuckle. Any question? Is there anything I need to answer about knuckle? I don't think the way I've taken my time to explain networking, I don't think you ever need networking again. And I don't think even when we get to the advanced, networking tool, you even ask problems again. Because I was just supposed to brush through, but I'm taking my time to explain it because networking is one of the things that if you don't understand in the cloud, you might never understand cloud. Okay. All right. So we are done with protecting the VPC, protecting the knuckle, the subnet using knuckle. Now we want to protect the service, the EC2 instances. What do we use? Security group. So security group, it uses what we said it is stateful. Stateful in the context that it remembers who came in. So if you allow somebody to hit your server and they are going outside, security group will not check them again. It will say, oh, you've already, move you outside, just come inside. Just go outside. But those who are coming in, take it as if the bouncer at the nightclub. They are not really checking who is going outside. Who is coming from the nightclub and going outside. But they are checking who is coming into the nightclub. Yes, that is security group. Okay, so security group, we mostly say it is stateful because it remembers that you've already come in, so let me allow you to go outside. But knuckle are stateless. Please listen to this English term. This is what they will use to beat you if you want to certify. Stateful means they remember that, oh, they did this, so they allow you to flow back. Stateless means they check both in and out. They don't care who you are. Regardless, they will check you. Okay, any question? Any question? Right, so we've looked at security group also. Now this is security group. So what are they doing? Look here, we can do what we call chaining of security group. Okay, so if you look here, they are chaining some security group. Don't worry, we'll be looking at that. So we can chain one security group to the other, change this one to this one, change that one to that. Is exactly what they are also doing here. Okay, now this is a continuation of the security group chaining that I am talking about. So as you can see, this is what security, this is server 1, this is server 2, this is server 3. Okay, so they can chain this one, security group that is responding to this one. They can say that, okay, you, this server, listen to the security group from only this server alone. So if you do it like that, this server will listen to only this one alone. It will not listen to any server. Okay, and we do this to also protect our what? Our instances. Then we will tell the database that, okay, you two don't listen to instruction from anywhere. Listen to only this person. Okay, so yes, we can change security group. We will create it and we will practicalize all of these. Any question? Any question? All right, so there is something called multiple layers of defense. Yeah, when we come to the VPC, we are protecting the VPC with what? WAF, Web Application Firewall. Now, we also have route table. If we don't route it to the internet gateway, it is not going to get internet. Nobody can reach our server. If we want to route it to the internet gateway, we go ahead and route it. We can use the knuckle also to protect the subnets right here. And then we can use the security group to protect the service. Any question? So we are doing what we call multiple layers of defense. We are not protecting at one side. We are protecting at different sides. Any question? Any question? All right. So let's go on. Now we are comparing security group and knuckle side by side. Okay. Now, security group is associated with the elastic network interface. Okay. And this is where SG is associated with. Now, if you take knuckle, they are associated at the subnet side. Okay. They allow only traffic. That is when it comes to security group. Well, security group, you can't say, I want to block particular traffic. You only go to security group to allow a particular traffic. Now, what do I mean? Let's go through this. Let's say I want security group. Networking, SG. Oh, what's happened? Have you people saw the security group? All right, it's right here. So security group, I can say create security group. See, when we get to the rule, we can say, let's say we want HTTP. Now, had it been I said I want to deny, where will I put deny? We can't put deny in here, okay? So we can either allow only on AWS, so far as security group is concerned. We can kind of deny. That is what they are trying to tell you. Now, when it comes to NACL does not work that way. NACL can allow and deny. So NACL does two ways. Security group is only allowing, NACL can allow and deny. Any question? Any question? Right, any question? Okay. Well, NACLs are stateful. That is security group, sorry. NACLs are stateless. Okay. So when it comes to security group 2, all rules are evaluated, okay, and then they are decided whether they are allowed or denied. When it comes to NACL, the lowest one is processed. So once the lowest is saying allowed, then to listen to it and go ahead. Okay, so it assesses it based on numbers. It does not check, okay, am I going to allow, or which one is saying allow, which one? No, it just check the lowest number. Okay, the lowest number is saying allow. Then I'll have to allow. That is all. Okay, so security group is applied to instances only. Okay, and then this one too, when it comes to the NACL, they are attached to all the instances that are deployed in the subnet or in the AZ. So if we attach it to the NACL, any server we put in there, okay, is affected by the NACL. This one is associated to their specific instance alone. That is the key unique difference between your AWS NACL and your security group. Now, we've presented all these solutions to the network engineer. So let's look at it if we can answer the questions that we had earlier on, which we had no answers to. Now, how can we make sure that our network has enough IP address to support our workload? Well, we will define the traffic using our what? Our CIDR. Okay, so we use our CIDR to make sure that we have a bigger range network. Now, the second thing is that how do we build a dynamic and secure network infrastructure in AWS client? We are going to use virtual private cloud to isolate a session and then use that site and protect it using WAF, NACL, and security group. Now, how can we filter inbound and outbound traffic to protect resources on our network? Yes, we will use NACLs, WAF, and security group once again. Any other question? Now, what did we do? We look at IPs, we look at VPC fundamentals, we look at how traffic is flown through these VPCs. Now, this is an architecture diagram, okay, which we are going to build right now. We'll put up something, we will build a VPC, then we will build NATs, we will add some internet gateways, we will go ahead, add some NATs, and then we'll even deploy resources into this service. Okay, so we will deploy resources and then we'll try to reach the resources and see that, okay, the resources in the private subnet, are we able to reach it? The ones in the public, are we able to reach it? We'll go through all of these. Okay, any question?
Yeah, Pansy.
Yeah.
I'm just thinking. So, from my understanding, for the VPC, we rely on the WAF for security. The subnet we rely on the NACL, and for the services we rely on the security group. So, can you build a network where, if you don't want to create a security group for the service to rely on the NACL alone, is that possible?
Come again with your question. Can you create a server that is not going to rely on a security group?
Yeah. Can you not build a security group and say, okay, let's it rely on the NACL, since the NACL has the allow and deny function.
The subnet part.
Yeah,
so this is what happened. See, you are at this building. So take this round thing to be a building, okay? Now, there is a security man here. There is a security man also here. Now, if this security man allows somebody who is looking for you, they will only get permission to the premises. Okay? So they can come and walk here all over, but they can't enter this yard. Why? This yard too is protected by another security personnel. So this security personnel must also allow them to come to this yard. Now, when they get to this yard too, they can also penetrate to this building. Why? There's another person also protecting that side, which is a security group. So if you protect this, you protect that, and leave this one, I don't know how they'll get into the building, because if you block all public access to your server, nobody can hit the server. The server is now private. Even if it's not private, and you block all the traffic that are going to hit it, it is just there. It is not going to listen to anybody. So it's like, okay, I have all the resources, but I'm not using it because my boss said I should not use it. Okay, so it depends on you yourself. It's an architectural decision. If you feel like your server should be open, or you should have security group that will open a particular port, then you go ahead. What you should also know is that even though NACL is more sophisticated than security group also has its own thing. Maybe you want to tune a particular traffic, okay? Then of course you can use what is it called, security group instead of NACL. Just like we have been using. We want to allow HTTP alone on the server. Yeah, we use security group. We don't go and use NACL. Why? Because when we block another server, it means all the people, not just this server, all the people here in this subnet, when we go and block HTTP, everybody here will not get HTTP. Not only we. Maybe we don't like HTTP, but another server like HTTP. Okay, so that is the main reason why you can't use one alone. But however, it's an architectural decision.
Okay, thank you.
Sorry, I have a question.
Yeah.
Yeah, sorry. When you create a VPC on its own, the subnet, at that subnet level, the security that is created there, which is the, what's it called, the NACL, are they created by default?
Yeah. So when you create a VPC by default, NACLs are created. That is how AWS made it. There are rules that are made. Now the rules is all traffic allow, all traffic deny, all traffic allow, all traffic deny. But then if you want to fine tune it, you can go in there and fine tune it based on your own preferences. Yeah.
Okay, thank you.
You're welcome. Gregory.
Yeah, it's about the architecture diagram. Except I don't understand it, but for the first availability zone, I'm seeing two subnets, or three app subnets and then database subnets, and then public subnets. So let's say there are three. Now, my concern the most has to be the NAT gateway being attached to the public subnet is the concern, because I thought from definition, NAT gateway is for private subnets to get internet access. So why then do we have NAT gateway attached to?
Well, so there's a saying that if you want to be rich, associate yourself with rich people. You know that saying?
Yes.
Now you are not rich. You are associating yourself with poor people. How will you be rich? So the NAT gateway sits in the public subnets, and it is able to kind of route traffic for this private subnet because it is in the public subnet. Because if it doesn't sit in the public, its own self will also not get internet.
Okay.
So it sits in the public subnet, but then it is able to do one-way communication for the private. Okay.
Okay. So it's actually sitting in there purposely for this.
Yes, purposely because it want to get internet connection. So I have money. So if you ask me some of the money, then I give you some. But if I don't have the money, if you ask me, I'll not get some for you.
All right.
Yeah, that is what is happening. Yeah. Yeah. Is there any other question I address before we do the hands-on? Any other thing you don't understand about VPC? All right, so let's go on and then try to create a VPC custom, and then we'll create the skeleton. The first place we'll create the skeleton, okay? And then we'll give it body. We'll start fixing some body. We'll give it hands, we'll give it nose, and we'll make it live, okay? All right. So let's say VPC, you can search for it. However, I have starred them here, so I'm not going to search, okay? But you can also go ahead and then search them. Now, those from correlation, you have a little bit of problem because this class is not really using labs like that. For me, I use hands-on. I don't use labs, okay? So what I am doing, please, when you go back there, try to practicalize it. Get console, practice it, go through it. This is the only way that when you go for interviews, you are confident that, hey, they give me VPC, I can create it, okay? Yeah, so that is it. Now, to create VPC, there are two ways. We have VPC and more, which will create everything for us, but we don't want to do that because we know what we are doing. Now, you only use VPC and more when you know what you are doing. You know what you want. You define them, it creates it for you. But we are going to say, hey, we don't want anything. We want VPC only. Why? Because we want to give it our own what? Features. Okay, what is the name for the VPC? I'm going to say Penti-VPC and say VPC-demo, right? Any name at all. I mean, I can give it Arthur, I can give it a name. I'm just using this name, okay? And look here, they're asking me that, what is the CIDR block that I want to give it to it? Should it be manual, or we have something we call IPAM? IPAM is a CIDR denotator, okay? Where you can denote all the CIDR that you'll be using for your network. So if you use that, if you go to IPAM like this, it's going to pick from the pool, but I don't have any IPAM at the moment. I've not created any IPAM because I don't have production environments. So we can define that IPAM and say, okay, choose from this side. So IPAM, take it like a sheet of paper that you've written everything, all the CIDR you want to use. I want to use 172. I want to use 10.8. I want to use 10.9. Yeah. So when you pull IPAM, it will just go through your IPAM sheet and take one of the addresses for you. Simple as that. I don't want to use IPAM. We are doing it manually. So I'm just going to say, let's use 10.0.0.0. Okay. Here we are defining a CIDR. A CIDR means how bigger do we want the network to be? Okay. So I'll say slash what? 16. Now, you can see it right here that CIDR block must be between 16 and 28. We can't go beyond 28. So let's see. Let's try to block only the first 2 bits, this and that, which will be what? Slash 16. But in this case, let's try to block only 8 and see if we can create. And we will say create. Look at it. CIDR block must be between 16 to 28. Okay, we will not create 28. Let's go beyond 28. We just want to see what AWS is going to do. When we do this, it's still not saying why, because we might be between 16 and 28. This is what I was telling you earlier on. So AWS only allow from 16 to 28. If you do with 16, it's going to give you 65,000 something IP addresses. So please take notes, okay? So I'm going to say slash 16, right? And say now, what is it called? No IPv4, because I don't want to use any IPv4. Okay, I'm not building a dual stack. If I want to build a dual stack, I'll go ahead and say IPv4. I don't want to build a dual stack. Okay. Now, we can also do some encryption on here, but I'm not going to teach you encryption at the moment. When we are doing more into security, then you understand the encryption side. Now, tenancy, we are not dedicating anything. We just want it to be a default one. So we can also decide to give it a tag, whatever tag name that you want to give it to it. I'll say create. So this is it. We've created a bigger VPC, okay? Now, we have to go ahead, give it subnet. Subnet is what? Okay, we have the bigger VPC. Let's go here. All right, we have the bigger VPC. So we will have to go in there and divide it. Okay, that's okay. We want to use this side for this. We want to use this side for this. That is what we are going to do. And this division is what I said is called the what? The subnet. It is an English word, subnet. Subnet, entire net, sub of a net, semicircle or subcircle. Okay, that is what they are trying to mimic for you. Now let's go. Oh, I don't know why it is taking too long to just create these, probably because of the internet. Anyway, let me go over. Well, AWS has been experiencing latency. I don't know what's happening, but there is some latency.
So, Quincy, while you're waiting, the CIDR block is specified for the VPC. Is it because we could have multiple VPCs within the same region? That's why we are specifying that CIDR block?
Yes.
Or...
So think of it this way. If you are going to get visitors and you want to prepare food, you can decide to prepare the food exactly the amount of people that are coming, or prepare it more than, right? That is what we are doing. So we are just creating the space, the bigger space that, oh, just be there. 65,000, because I don't know what we are coming to do. But okay, let me take all the 65,000, put it down, and then let's go and do something. What we are going to do, I'm not sure we even deploy resources up to 10. But you see, I've taken all the 65,000 and reserve it. Yeah, that is it. So it is not by force. It is tied to what you are doing. Okay. All right. I think it has provisioned the VPC now. So we can go here and then we can see it right here. This is it, Penti VPC. Now there's something called resource map. It is very, very important. Now go and look at the resource map. Let's go and look at it. So I'm going to say this one. I'm pulling it up a little bit. I don't know, but kindly forgive me. My screen now has been misbehaving when it comes to resource map. I don't know whether it's AWS that has made it smaller like that. I've tried several times to make it bigger. But look here. You see, this is where you can track what is happening. This is your VPC. Now, if you look through, they've only created one route table for you. One route table. It's right here. Now, you don't have network what? You don't have internet gateway, you don't have NAT, you don't have subnet, you don't have anything. So look here, 0 subnet, one route, which is the main route. So what AWS is saying that, okay, we have created a road for you because we don't know where we are going. So there's a road. Whether you want to pass the road, it is for you. If you want to pass there, it is for you. But get to know that road is public road, because AWS, whenever they create something for you, it's public. So that it's public road. If you want to use this, that is fine. But we are going to say, hey, we don't want that road. We are never going to use that road. So let's go ahead and create a subnet. Now we will say create subnets and say for which VPC. Okay. So select the VPC from here and say for Penti VPC demo. Go down and say, okay, let's give the subnet a name. We want to create 2 subnets. One for private subnet, one for public subnet. So let me just say private subnet. Okay. All right. Private subnets. And then because subnets live in AZ, they are asking you that which availability zone. Now, if you leave it as no preference, it's just going to select one. If you leave it at no preference, it will select one of the AZ and use it, because what you are saying is, I don't care wherever you want to put it. That is what no preference means. Okay. But I am going to say specifically that, okay, leave it at 1A. Okay. It's 1A. And then look at it. There is a subnet for the CIDR block. So IPv4 subnet CIDR block. So there is a CIDR block also here, which is for the VPC CIDR block, as you are seeing it here. What is happening? See, this one is for the entire VPC. And you said you are coming to divide it. So AWS is saying, okay, look on here. This is the bigger one. So if you want to divide it, what do you want to use? Now, let's assume that I said I want to use all. I want to use everything. So let me define 10.0.0.0 and say /16. Look, it populates it for me, 65,536 IP addresses. It's telling you that, okay, if you use this, this subnet will have 65,000. What it means is that, hey, I've created a bigger circle. By the bigger room that I created, I didn't want to divide it smaller. So I've made one big division that has covered the entire thing. Simple. That is what I have done. So let's create it and let's mimic to see if we can create another one. All right. So I am just going to say create the subnet. Now we are creating the subnet. Let's go on here and say subnet again. Okay. It's in the creation stage. I don't know what is happening. Of late, I've been experiencing some higher latency. I don't know if I have to write to AWS, but it looks like Africa, Ghana to be specifically, we are experiencing some higher latency. Still delaying. All right, so let's say subnet again and then give it some time to load. Let me go to Penti. And then we want to create another subnet. So let's name it public. Okay, public what? Subnets. Right, so AZ, I'm going to say 1B because we put the first one in 1A. And then when they ask me for the CIDR again, look at what is going to happen. We have used all the 65,000 to create one subnet, which is the private subnet. And we want to create again. What it's going to do is, okay, you've taken the whole portion for only this one. And you are saying you want to come and cut the portion again. The land is finished. So which side are you going to cut? So let's look at what is going to happen. Let's go to this side and say we want to use 10.0.0.0 and say 1, 2, 3, 4 and say slash and say okay, we want to use 24. Okay, and it's saying okay, slash 24 is going to give you 256 IP addresses. Let's look at what is going to happen. So if you write it, it populates the address for you here. Create. Let's see. Look at it. Error. There was an error. Why do you think there was an error? Because you see, it's saying CIDR block this conflict with another subnet. Because you've cut the entire thing, use it for one person, and you want to cut another portion. So there's nothing available again. There's the subnet don't know where to go and cut again. So what do we do? In this context, we will have to go and delete it. Okay, go and release it back to the owner. Release the land back to the owner so that the land can be reapportioned again. So we will have to go to the subnet and say, okay, we are looking for private subnet and say we want to delete it. We delete the subnet and say delete. And say hit enter. There you go. We've deleted that. Okay. And then we are going to say go ahead. Okay. All right. So we will say back. Now we are going to create the server again. So we want to call it the public name and say, yeah, we will say /24. Let me even do it /17 and say you want 65,000. Yeah. So what I'm doing is I'm allocating first one to it. Okay. And then I'm saying that, hey, I'm cutting first one. The first one that I'm cutting, the figure I put here is going to determine how many IPs I get. So if I put /28, look at 28. 28 is going to give me what? Just 16 IP addresses. Look, 16 IP addresses. But I'm saying I don't want it. Okay. So I will say 17. If I change it to 18, it will reduce. It will keep on reducing based on what I want to do. Okay. So I'm going to say 17 for public and say create it. That is it. And say create another one. I want one for the private. So I'll say create. Now I'll say private subnet. Right. And say that one was in 1B. So I'll put this one again in 1A. And then we will say 10.0.0.0. Okay. /24. What I'm saying is, hey, I don't want bigger subnet for my IP. So I just want something small with 250 IP addresses for my private. Then I can go ahead and say, create this. What is happening? Okay, it's crashing with 24. I don't know what is happening, but let me do it 28. When I'm done, I'll show you how to go around this, okay? Or it's still crashing. I don't know what's happening. Oh, I should have changed this number. Hold on, let me change this one to 2 or 3 and see. Let me see if it still crashes. I'll show you how to go. All right. So one of the things, it's even funny to me. One of the things that network engineers, cloud providers, cloud engineers, it has been our nightmare is to divide a subnet division. It is one of the hectic work for us because you can't do the calculation off head. So most of the times, I'm telling you what I use. Now, if you are a networking engineer, you can do the calculation using your own tools. But however, I do not worry myself to do the calculation. So I just use what? AI. So I tell AI, so I just tell AI, I have a subnet of 10.0.0.0.0/16 for a VPC. I want you to divide it into 2 for me, for a private subnet and a public subnet. That is all. Then I tell AI goes ahead and then it's going to do the division for me. However, if whatever tool you want to use, go ahead and use it. Nobody will arrest you for that. Okay. All right. So they are telling me that, okay, use this one. This one should be for the public. This one should be for the private. All right. And each one is going to yield a total of what? Of 32,000 IP addresses. Okay, so let me see. Let me use this one. I think we did this one for the. So, can you still hear me? Can you guys hear me?
Yeah, we can hear you.
Okay, all right.
Yeah.
All right. So hold on. Let me quickly change this to see if it's going to work. Right. And then let's go on. Right. I'm sure it's going to go through. Well, let's wait and see. So that is it. Don't let subnet division hold you up. If you can't divide it, give it to AI. There are tools around. Give it to tools to divide it. Don't go and break your head into 2 because you can't section a subnet. If you need 5 subnets, tell AI you need 5 subnets. If you want it equally, tell it you want it equally. If you want one to be bigger than the other, it's just a prompt. So give it a prompt. It's going to go ahead and do the work for you. I don't know why it's still taking higher time to finish. Let's give it some time. If it doesn't, I'll delete the 2 of them and we will recreate it again. So until it's done, let's just wait for some time. Now, let's look at what we've done. Where have we gotten to so far? So let's go to VPCs and go to resource map. Let's look at our resource map. Now, this is our resource map. Let's go here. You see, we have a public subnet created. And look at that. You see, once we created the public subnet, it is using the road that was created for us by AWS. Okay, as you can see it right here. Okay, so we have just one, meaning the other one hasn't created. Okay, it has created. So let's refresh this one. Let's say refresh. Couple it again and go there. We should see 2 subnets. Yes, you can see 2 subnets right here. Look, private subnets, public subnets. They are all using one road. Well, can the president and the individual use one road? Yes, even if they can, there are some restrictions. There is some place you can't pass where the president will pass. Okay. Yeah. I mean, if you see the president, that's where you know that there is no limit to speed. Okay. Yeah. So let's go ahead and then do all of these. We've created a subnet. Okay. We've created 2 subnets now. Now we need a road where each and every one should pass, because private road should be different from public road. So what are we going to do? We are saying, okay, we need a road because we have 2 places. So let's go to route tables and create a route. I'll call this one public dash routes. Okay. And I'll say which VPC, Penti VPC, and I'll say create routes. Now, route has been created. Okay, we've created a road. By which subnet should use the road? When you create it, you are done. Then come to associations. Association. And say edit association. Explicit edit. So which one did we create? Public. Select only the public and say associates. Okay. Now let's go to the resource again. because we do not know how to create VPC. Or if I'm the one using, I will just close my eyes, I'll create them and come and look at it. But because I'm doing it with you, let's look at it one by one to see what we've done. Okay, yeah, we have two roads now. Now the public road is using the public routes. Ah, that is perfect. Okay, let's go and create one for the private. Okay, we can decide to delete AWS one, but I'm just leaving it. We don't have time. So let's say route table one more time and say create another route and say private dash routes. Okay. Now, which VPC? Penti VPC, and say create routes. When you create the route, you should associate it to a particular subnet. So I'll say association and say edit association and say attach it to the private so that the private will use that route. Now, what have we done? Let's go to the resource again. We refresh it. Let's see if we are doing the correct thing. Yeah, we should. What's happened? Why has it delayed? Oh, we need to select it and say resource and go down here. So look at that. Private is using the private road. Public is using the public road. Now the road that AWS created for us is useless. Nobody's using that road. All right, let's leave it now. Now, what are we going to do? We need to attach an IGW to the public. So we need to tell the IGW that, okay, even though you are using the public road, now you can't go over the internet because you don't have what it takes to be connected to the internet. So we will have to connect you to one man. His name is IGW. So let's go and look at that. So let's go here and say internet gateway and say create an internet gateway. And I'll say Penti -IGW for Penti internet gateway and say create. All right. When you create an internet gateway, you need to attach it to a particular VPC. Now, what we are going to say is that attach and go ahead and select what Penti VPC from here. Or however, let's say you created it and then you quit it. Okay, you didn't know what happened. Maybe the screen went off or something. Yeah, you have the internet gateway, right? Just select it from here and go to actions and go to attach and go to the VPC. Select the VPC from here and attach it and say attach. That is all. Now, you have internet gateway. Let's go and look at the resource one more time. We will look at the resource map until we are now conversant to create VPC. So let's select Penti VPC and the roadmap. Go here one more time. Now we have it here. Why do you think it's not showing? Because the same road that we told what? The route table that, okay, if you are going here, pass here. You remember when we were here, when we created the subnet, we had to go and tell route table that, okay, tell this person that if they are going here, they should pass here. So that is the same here. If we want to come and use this one, we have created it. Then we need to go and tell the route table that, okay, if you are going here, go and pass here. So what will you do? Let's go to the routes. Let's go to routes, public routes, because we want the public route to have the internet gateway. So let's go to public routes and say routes and say edit routes. All right, so currently you see it is only local, so it doesn't go over the internet. It's just, this is the IP, the CIDR block of the IP, and it's saying any IP that falls within this, route it locally, don't go anywhere. What we are also coming to say is that add route. What is the route? 000. We are saying, okay, if you want to go to the internet, come and use internet gateway, and we will look for internet gateway from here. It's going to ask you, okay, which one specifically should I use? Select the one you created, which was what is called Penti IGW. Selecting that one and saying save. Simple as that. Now, let's go back to our resource again. So let's select this one and then go to resource map again. Go here one more time. So look at what is happening neatly. Now we have internet gateway that is routing through the public subnet, the public route hitting. Now what we have done is we have provisioned a VPC, created a VPC, subnet it, usher an internet gateway, route it through the public subnet to the internet gateway. And now we'll be able to deploy resources into this particular subnet. Any question?
The NAT gateway, are we here to do it?
Well, we've not created NAT. We are doing one after the other. So we are now concentrating on public subnets. Because even if we don't finish with with a public subnet for you to get internet, we cannot create where would the NAT sit. Okay. So let's focus to get internet for the VPC first. Then we do the other thing. Is this clear? Do you understand now?
Yeah.
How many hours are we left with today?
2 hours to go.
Oh, we are left with 2 hours, 2 more hours. All right. Because we'll try and do compute or we'll try and do storage before we close today. Hold on, give me a second. It's 6 p.m. All right. Okay. Is there any question before I move on? Is there any question before I move on? Now, we didn't create Knuckle. We didn't create WAF. We are not going to create WAF for anything today. But let's go and look at our Knuckle. Now, let's go and look at our Knuckle, or just let's hit. This is our VPC. Let's open it. And then this is what the Knuckle that is associated with our server. Now, remember we created two subnets. So what did they do? AWS took the subnet and they created a Knuckle for us, and they attached those Knuckles. So what they mean is that, okay, this rule should be applied to all these two subnets, and that is our subnet here. Let's go into the Knuckle to look at it. Edit. Look here. So there is one that is 100, just like we saw earlier, and then there is also one that is block all, and AWS has even what kind of grade it out, because AWS is evaluating the rule based on the smallest, which is the 100 in this concept. Okay. So any other thing, let's look at the outbound. The outbound too is doing the same thing. So look here. Simple as that. So we'll say cancel. Now we've created it. Let's go and provision a server and put it into the VPC. Right? So before we will do that, let's just get something, either, what is it called? Let's get a user data that will go onto the server, and then it will be deployed for us to know. So let AI help us create a user data, because I don't want to type anything. Hey, can you give me a user data that is going to run on EC2 server? It's going to run on Amazon Linux 2. Let it just say, hey there, this is from a public subnet. Let it be bold at the middle, and also color it using red, not red, orange. Okay, give it orange and white color, and let it display at the middle of the web page. Let this be a user data. All right, so let's create a script for us, and then we are going to run the script. We are going to give it to a server and provision it in our VPC. So let me go here and say launch VPC, and say launch without a walkthrough. What is there? Let's say public dash server. Okay. All right. EC2 instance. I do not need a key pair because I'm not going to SSH. Now we are going to touch network settings. Why are we going to touch network settings? Because that is where we will choose our VPC, the kind of VPC that we want to use. Now, if we leave it, it's going to use the default VPC. So we will click on edit, and then we will come here and we will say, okay, don't put it in VPC, put it in Penti VPC. And it is going to ask us, which subnet should I put it in? I'm going to say what? Public subnet. You see, we have only two subnets. So I'll say put it in public subnet. And then it's asking you that, hey, should it use DHCP? Should it automatically assign a public IP? Well, if you want to use elastic IP, we can go and use it. But I'm going to tell it that, yeah, enable, just automatically assign public IP for me, because I don't want to go and provision elastic IP again. Okay. Now, when it comes to the security group, which what are we expecting? We are expecting a website, so HTTP, not SSH. So we are going to say HTTP right here and say anywhere IPv4. Now, you see what I told you initially, that you might be seeing something, but you just didn't pay attention. Now, if I do it my IP address, it is going to give me slash what? Slash 32. Why do you think you are seeing slash 0000 slash 0 here? Because it's saying all these bits are open. But if you see slash 32, it's telling you that all the bits are blocked. So it should be the exact IP. So look at something. Once I select my IP, look here. You see, that's giving me the exact my IP address with slash 32. So meaning this one is blocked. This one is blocked. This one is blocked. The last one, the 27.2 is what? Is blocked. So nothing should be changed. That is what the system is telling you. Okay. But I'm not going to do it my address alone. I'll say anywhere and say go in. Well, so this is going to be a storage, and I'll say advanced. I'll go and say user data. I'll say paste this one here, the one that we made the chat did for us. I'll paste that one here and say launch. There you go. So we have launched something into the what? The public subnet. Now let's see if we will be able to reach it over the internet. Once we are able to reach it over the internet, it means we've done a perfect job. We've created a VPC, created a subnet, deploy a resource, and then we are reaching it over the internet. We've done something. Any question? Is there any question before we continue? Any question? Is there any question? Is there anything you don't understand? Is there anything you want me to repeat? Is there anything you want me to iterate again? Right, so let's go on here and say, let's visit the server. Right, so they've given us an IP, right? So let's try to open the IP to see if indeed it has deployed something on there. But it's going to listen on HTTPS, which we don't have a certificate. So you have to remove the S here and then hit enter. There you go. Hey there, this is from public subnet. Any question? Any question? Is there anything I have to know? Is there any question you want to?
With the HTTPS, is it a matter of configuration or a port will not open?
Is it a matter of no, you can't just, even if you open HTTPS, before you can route on HTTPS, you need a certificate. You know it, right? So we don't have the SSL TLS certificate. So even if you open the port, we still don't have the certificate.
All right.
Yeah. All right. Is there any other thing? What's happening? Why is my this thing not going? Which one did I use? This red thing here. I don't know why it's not going on. You are seeing some red thing on my screen, right? This one. The one here.
Yeah, I can see it.
Maybe it's not on this page. So I said it. It's not on this page. It's not on. I said it is on this one rather. Oh, that's why. Hey, it's not going on. Let me try.
Hello, bro.
Yeah.
So as a solution architect, like this structure you are showing now, like this table, are we expected to be drawing this table like this to explain?
Yes.
Everything?
So as time goes on with the program, I'll show you how to draw architecture diagrams. Okay. I'll expose you to tools and resources and how to draw architecture diagrams, because before you present a solution to a company, you need to draw it. The company will have to understand, oh, this is what you mean, this is what I mean, and you show it to them and you explain the architecture diagram. Now, after this program, any architecture diagram you see, you should be able to interpret it and mean, oh, this is hitting this is making a request to this side. Yeah, so we will get there. Okay. All right. Since there are no any other questions, well, I don't know what's happening. Frankly, I don't know where from this. I don't know what's happening, but I'm seeing. I honestly don't know. because I'm trying to clear it. It's still not going. Okay. Let's leave it. Yeah. Okay, so that is it. We've been able to hit our server using our what? Our public what? Subnet. It means that the subnet is responding. Everything is working fine. Now we can deploy resources into our what? Our subnet, which is the public subnet. Now you remember I told you something that we can do what we call chaining of security group. Now let's say we come here. We have what we call front end. Okay. And we have what we call back end. And we have what we call database. So this is database SG. This is front back end SG. This is front end what? SG. So let's go and create security group of that sort. Let's practicalize that one too. So when we go to security group, under security, it's right here. Okay, I can say create a security group. Now, what is the name? I'm going to say front end, dash end, and say description. I'm just going to say allow, and I'll say Control A, I'll say C. I want to copy to iterate the other one. Now, which VPC am I creating the security group against? Because security group lives in a particular what? VPC. Regardless that they are also sessioned by the Elastic Network Interface, they also live in that VPC. They don't go outside the VPC. So I'm selecting the particular VPC and say, what is the rule? Maybe I want to expect everything that is HTTP from anywhere over the internet. Okay. And I will say, yeah, because it is stateful, we don't go to outbound. Don't change anything outbound. When you are working on security group, leave outbound alone. Once you go and touch something at outbound, your ears are becoming hot because your traffic might not work. So make sure that when you're working on security group, do not touch outbound. Now we've created first security group. Let's create another security group also. And say we want to create security group again. We should call this backend -end and say allow. You can give the description any name. I'm just doing allow. Okay. Now, when it gets to the inbound, I want to say that, okay, you the backend, okay, listen or route traffic to only the front end. So I will say here that, okay, what is the traffic I'm looking for? Let's say TCP or TCP. And I'm saying which ports. I'm going to say what specific. I'm not opening to anywhere IPv4 because once I open to anywhere IPv4, hackers, thieves, everybody will just be trying to hit my server. So I'm going to say, okay, listen to only a particular security group. So what it means is any server that security group is tied to, listen to only that server. Now I'm going to look for front end that I created for my front end server. So look at it, it's right here, front end. That is all. And then I can go ahead and create it. So this is called chaining of security group. You create one, you create the other, and you chain the other to the other one so that you add this one to this one. Then this one is going to listen to this one based on the security group alone. Okay. Yeah, it is also done and it's practicalized. Had it been, we also have some database. So let's say we have some database. Okay. We have some database. We will say database. Data, we say base, and say that's SG, and say allow, and say Penti demo. What is the inbound? I'll say maybe my SQL. Okay, I'll say okay, maybe my SQL Aurora. Listen from which source? Where would the traffic come from? I'm going to say back end. It will also not come from front end. So I'm going to say back -end, and it's right here. You see, it's populating here. That's all. So the database will not listen to any server apart from the backend server. Why? Because you iterate it here and you've done what is called security group chaining. Any question? any question. Now, yeah, Gregory.
Yeah, so I think I was working on a project like that, and the AI told me to open TCP for backend, and I kept wondering, and you also did the same thing here.
Oh,
I'm wondering
I'm
why.
just opening the traffic. It depends on the traffic that you are listening to, because most people, when they hook it to the front end, it is TCP that they listen on, right? Yeah, so
Yeah.
it is not something like, it depends on the traffic you are listening. If you are listening on TCP, go ahead, opening it on TCP. If you are not listening
Okay.
on TCP, just choose another port and then hook it to it. That is all.
All right.
Yeah. Yeah. Is there any other thing we have to look at? Any other thing you want to know? Okay. So we are going to look at what another concept again. Now, we will look at what is called so let's go and create a server again and say launch instance. This time around, we'll put it in the private subnet, not the public. The public we've been able to do. We are hitting the server. Let's put it on the private subnet. Okay. Now let's copy what this resource give us. By then, maybe we can try to change, hey there, this is a private subnet. We will do it, hey there, this is a public subnet or private something, depending on what we are creating. So we are going to say private. We should hurry up because we will be doing something before we also close. And then I don't need a key pair though. So I'm going to say proceed without a key pair, edit. When it come here, VPC, I say, okay, I want to deploy it in the private subnet. Even if we tell the DHCP to give it an public IP, we'll still not be able to hit it. So we can even do enable it, okay? And we'll still not be able to hit it. So when we get here, you remember we've created some front end and we can use this one for that. So it's right here. So the front end is allowing HTTP, so we can use it, okay? Then when we go to user group, we will say that, okay, we want to do this, but this time around, we are saying private, not public. Private subnet, yeah. And say go ahead and create it. There you go. That is all. So let's see if it creates, will we be able to get access to it outside? Okay. All right. Now, this server in the private subnet, it does not have any connection to the internet. Even it can't do even updates. Even if it want to update itself, it cannot do because it's not connected to the internet. So before it can do update on its own, unless we hook it with what? With a NAT gateway. So this is what we will be doing next. Let's see. All right, it's creating. So let's see. All right. We are hitting the public subnet, even though it's in the private subnet, right? So let's see. Let's look at what will happen. Yeah, that should tell you it's not even going to work in the first place. So it's going to load to give you error, to keep on giving you, iteratively giving you error. Why? Because the IP you are trying to reach, even though it's IPv4, which is internet routable, where you are trying to go is a confined area. People have protected the area. So I can't enter where you are asking me to go and fetch the information. That is what is happening. Okay. So it's iteratively going to just rotate, give us error, rotate, give us error, rotate, give us error. Even if we go and add NAT gateway, it will still not come. Why? Because NAT is a one-way communication. And what we are doing literally is we are saying, okay, take this information, go and give it to the server, which NAT don't do that. NAT will only take the server and bring it outside, but it do not take your information and give it to the other way around. Okay. So please, that is it. That is how you can demonstrate that your subnet cannot be reached over the internet. Now, you can also try to update the server. It will not work. That's when you SSH into the server. Maybe you use Instance Connect or Cloud Shell. You try to update it. It's not going to work because it does not have internet connection. anything? Is there any other thing you want to know? All right, so let's add NAT. Well, we will not add NAT and let's not do anything because I'm not going to do update or anything, but I just want to add NAT to demonstrate to you that NAT can be added, okay, and how NAT is added. So let's go here and then under VPC, let's go to NAT gateway, not network. Oh, let's go to NAT gateway. Not transit gateway. People sold my NAT. Yes, it's right here. NAT gateways. So we will create a NAT gateway. I don't know why it's delaying. Yeah, I'm going to say NT-NAT. Okay. Now there are two. Hold on, give me a second. All right, so there are two ways to create NAT, okay? There is one that is a regional service, okay? When you create it, it automatically scale and then it covers the whole region, just like the VPC is. So wherever you want to create NAT, it is working, it is already there. However, there is a zonal one where it exists in a particular AZ and it does the NATing there, okay? So it exists in that AZ and be doing the NATing. Well, if you use regional, it becomes redundant or high available. If you use zonal, the probability that if that zone is down, the NAT is off. Okay. So mostly in a real-time environment, please go ahead and use the zonal. However, I'm going to use, in a real-time environment, use the regional. I am using the zonal. Okay. Now, they are going to ask me that which subnet do you want this NAT should sit in? Well, I want the public subnet. Look at it. It's right here. Public subnet. Sit in the public subnet. And then they are asking me, what is the connectivity? Do I want it to be connected to the internet? Yes, I want it to be able to go over the internet and fetch information. Okay, so I'm saying yes. If I want it, if I don't want it to go over the internet, I want it to be private alone. I can also choose private from here, but I want it to go. Now, NAT, because it will go over the internet, it needs an IP. But NAT does not already have the IP. So I have to call an elastic IP, static IP, and give it to it. So look here. We have some already, but I'm not going to use this one. I'm going to say allocate an elastic IP. Click on it. And that is it. It has allocated an elastic IP for it. Okay. And that is all. You can say create NAT. That is all. The NAT has been created. However, there is still a problem. Why is there a problem? Because the NAT cannot be utilized. You've not told the private routes that, okay, when you are going over the internet, go and pass through the man called NAT. You've not told it. So you have to go there through the resource. So let's come here and say resource map. Go right here. You see, now we have two network connections. If you look at the NAT is not connected to anything. Look here. So please, if you are creating or you are mimicking this and you have problem, go to the resource map. Go and look at it. Now, what do we have to do? We have to go and make the connection from the public route to the NAT. So I'll go to my routes table and I'll see the private routes. And I'll say routes and I'll say edit association. Okay, edit routes. Now, I'll say add routes. What I'm going to say is 000. Hey, private route. If you want to go over the internet, 000. Go through the internet, the NAT gateway. So look at it. I'm saying, if you want to go here, go through the NAT gateway. And it's asking me which NAT. And I'm saying, oh, Penti NAT. Use Penti NAT and say save changes. That is all. So now, if you go and check, you should have the NAT to being what routed through the private gateway or through the private subnet. Now look here. Let's go here. Look at it. Simple as that. You see, This is the public. This is the private. Look at the private. Now it's routing through the NAT gateway, meaning it also now the private has internet, one-way internet. It communicates outside. Outside does not communicate with it. Any question, any problem, any answer, any addition?
So it means that if for some reason I'm able to enter an instance in the private subnet, I'll be able to do probably updates or something now because we are connected to
Yes. Yeah. So if you're able to SSH into the instance, maybe using a jump box or using a systems manager, you can do updates now. Okay, you can update it. You can install HTTPD because why you still have this installed. Okay.
All right.
All right. Any other thing? All right. That is all for VPC. However, let's quickly go through the questions. Then we can go over the next thing that we want to iterate today. Right. Okay. So let's look at the knowledge check. True or false? A single Amazon virtual private cloud can span multiple regions. True or false? VPC can span multiple regions. True or false?
False.
Yes, that is false. So let's look at that. The correct answer is false. Now, which action must be taken to make a subnet public? What is the action? A, route outbound traffic from the subnet. Well, B, route inbound traffic from the internet gateway. And then C, route outbound traffic to the internet gateway. D, subnets are public by default. It is a lie. So let's understand what they are saying. So it means they are telling us the route. Now let's visit the route one more time just to understand what is happening. So public routes. Let's look at the public route. What did we do? When we go to the public route, we go to edit route. What did we do? Outbound destination. Where is going? Outbound. Where should they pass through? They should pass through the IGW. So outbound should now pass through the IGW. Now let's go and look at the question one more time. What is the correct thing?
C will be correct, but then I also have a question on that.
All right.
If you're saying IGW is to allow traffic to and fro. Now, if you say that outbound, that means that we are looking at going out the let's say resource or an instance.
Yeah.
How about somebody making a request to the resource? Isn't it an inbound traffic?
Well, so this is what happened. Now, because it's a two-way communication, when you state the outside or the outbound, you don't have to necessarily state the inbound because on a two-way communication data. It is not like a NAT. A NAT is one way. Okay. So that is the difference between the NAT and the IGW. The IGW is a two-way. You state that, okay, if you're going outside, go here. Now, have you also looked at how, so look here. So when the traffic is coming from the outside, the user has made a request. Which resource will it meet first? It is always the IGW. It is always there. So it is not just an IGW. It does some I'll say intermittent. I don't want to use any technical word you will not understand. It does some internal routings. Okay. It's also able to kind of help route the traffic. Okay. It's trying to hit the NAT or it's trying to hit the public or it's trying to hit the private, that kind of thing. Okay. So it's a two-way communication. It's not just doing one. But you specify one, you leave the rest. That is all. It's going to work automatically.
So when I specify outbound, I'm taking care of both.
That is all. That is all. Okay, once the outbound is open and it's open through and connected to the IGW, that is all. You are literally telling the subnet that, hey, you can be reached from in and out.
All right.
That is why, when we did here, did we specify outbound and outbound? No, but we were able to hit our server. Why did we hit the server? Because it's a two-way communication. Arthur, do you want to ask me a question?
No.
All right, that's fine. Is there any other question before I move on? All right, so let's go through these. All right, yes, so the correct answer is route outbound traffic to the internet gateway. Now, what function does the NAT gateway serve? Look at the function of the NAT gateway. So tell me what it does. What is the function of the NAT gateway?
That's B.
That's B, allow internet traffic initiated by the private subnets. All right. So let's see. Yes, that is the correct thing. Now, what should be used to create traffic filtering rule for subnets? What should be used? I mean, they're asking you, what should we use to protect the subnets? Simple.
D, NACO.
ACL.
C, security group.
D, NACO.
Listen to the question well. We are talking about subnets, not servers. Servers are protected with SG, security group.
Yes.
Okay.
NACL.
NACL.
NACO.
That is it. That's the correct thing. Right. So let's look at this. We have to select two. Which ports are open by default when a new security group is created? They say we should select two. Which ports are open by default when a new security group is created? Now, when a new security group is created, something wonderful happens. Or something is denied, and or something is allowed. So, what do you think it is? A new security group. Come again? All right, I like doing hands-on. Let's go here. Okay. So let's see security. Right, let's look at security groups. So let's say create a security group. We will say try. Oh, what's happening? All right, even with this one, let's look at what is happening. Because the answer is right here. Look at what is happening. This is inbound rule. You see, nothing is there. Now, this is outbound. Outbound is having what?
Explicit rules. Traffic.
You see, so now let's go back to the question again. What is the correct thing?
It will be C.
We have to select two. Check here.
Oh, sorry. It will be C and E.
C and E. Are you all in support? C and B. A.
A.
Gregory, are you sure of B? Because I'm seeing outbound. Oh.
A and D. Let me say A and D. I don't know.
All right. A and D. And D. All right. Let's look at it. Now, let's even look at it before we look at the correct thing. Now, if we come here, you see all inbound rule is denied by default. There's no rule here. So it means everything here is what? Denied by default. It's not allowing anything. By all outbound.
What means all inbound rules denied means that nothing is going to be allowed in. Is that what you're saying?
In. Okay.
By default.
Out. Yes. Out is the one going outside the the server. In is the one coming into the server. So the outbound, as you can see, because it is stateful, they already allow all traffic to be flown outside. That is why when you are working with security group, you don't have to specifically say a certain traffic should go outside. Why? Because they are stateful. Okay, so you can see it here that all traffic is allowed outbound, but inbound, nothing. Right? That is why I showed you this to answer the question. All right, so let's see the correct thing. We are looking at A, nothing is allowed inbound. Yes, of course. And D, anything is allowed outbound, anything that want to go outside, because it is stateful, it has already been made that everything should be flown out. By something that is coming in, nothing should be allowed by default, unless you specifically state the rule. All right.
So by default, once you create it, it locks every door until you have opened the...
That is it. That is it. Yeah, is there any other question?
No, that's right.
All right. Okay, so that is the end of the model. Now let me give you about 10-minute break, and then let's start with the second session. I will try and not make it too interactive like that, and so that we will be able to beat time, because I think we have an hour remaining, right? We are left with an hour. Am I right?
Yeah, that's right.
Yeah, so
Just more or less.
yeah, so let's get about 10-minute break, get up, stretch, get something. If you want to enjoy some music, and then let's come back in the next 10 minutes to finish. I think we'll be doing storages or compute, if I'm correct. I'm not so sure of the one we are doing, but let me check before we go out for break. All right, we'll be doing compute. So we are on compute. Yeah, we'll finish compute. Don't worry, it's not really bulky like that. We'll finish with compute before we will go. Is there any other thing before we go out for break? Right. Okay, so let me pause the recording, then go get some break. It's a machine that is able to do some computation, do some calculation, and then yield profit. Now, so far as AWS is concerned, there are a lot of compute on AWS. So today we'll be looking at some of the compute and even how the compute came about. Okay. So as usual, we'll start off with some business requests. We'll look at compute services. We'll dive deeper into EC2 instances. We'll look at instance storages. We'll look at pricing option. We'll also look at AWS Lambda, which is also a compute. Now, we'll present the solution to the business request that was asked earlier on. Sorry. We'll present the solution to the business request that was asked earlier on. So we answer that. We also look at some knowledge checks if time permits us before we will go. Well, when it's come to building our that is project 2. I don't know why I label it like 2. When it's come to building our VPC infrastructure, I think we've done a lot of that already. So I don't think we will have any hands-on again on VPC because we did it the first time. Well, let's start with the business request. So what AWS compute services are available? Well, we don't know. We don't know any of that, okay? What should the team consider when deploying a new and existing server to Amazon EC2? Well, we don't know. We don't know what they have to consider. Honestly, we all don't know. How do we know which volume type to attach to our EC2 instance? We also don't know. So how can we optimize cost for compute resources? We also do not know. Where can we start with serverless compute option? We also don't know this question. So let's go on as a solutions architect. Let's go and answer the first one. What are AWS services? I mean, what compute for AWS services that are available? Now we are going to start with the evolution of computing. So AWS started from 2006 with virtualization. Now, I don't know if I've explained virtualization in this class before, but virtualization is just a computer. Now, physical computer, and then they install a software on it called hypervisor. So the Hyper-V, what it will do is once it has been installed on the physical computer, it will allow you to kind of create a virtual computer. Now, the advantage of using this system is that the physical one could be running Windows. The one that it will provision virtually for you could be running Linux. This one could be running Mac OS. Now, you can put this one off. You can restart this one. You can put this one off. You can restart this one. Whilst your physical server, which is the physical laptop or whatever machine that you are using, is still there. So they mimic the real-time environment, the physical one. You can put them off, you can delete them, you can provision them, you can give them storage. By behind the scenes, what they are doing is that they are just using the resources that exist on the physical one. So this is how it goes like. Now, let's say this is the physical one. It has a storage of 1 terabyte. Okay. So 1 TB. Now, and with a 32 GB RAM, so 32. Okay. So now what is going to happen is that when we provision a virtual server, out of this 32, it will come and take some. So let's say we provision first one, we give it 8 GB, and we give it a storage of what? 200 GB. Now this one has now reduced to what? 800 GB and not 1 tera again. So physical storage has been reduced. This one too, we've taken 8 out of that. Okay. So we are left with what? With 24. Why? Because now it was 32, we took 8 out of it. So the RAM 2 is left with what? 24. Now, if you create another server, that server 2 will come and take this one. So let's assume the server 2 comes for what? For the 4 GB on the 24, and with a storage of what? Of 300 GB. Then it means this physical laptop is left with what? 20 GB RAM of what? 500 GB RAM and not 1 tera again. So behind the scenes, they are just using the physical resource of the host, the one they are existing on. That is what we call virtualization. So the way you are able to get EC2 compute through the internet is through this thing called what? Virtualization, which is what is using this technology. Any question? Any question? Is there anything you want to know? All right, I guess take that as a no. So they started with virtualization for some time. That is from 2006. Virtualization was what they were using. Then along the line, when we build softwares, because we are not able to bundle it, if we send it to another server, it crashes. It's not able to run. So they came up with something called containerization. Containerization is like, it's like a box where we put everything together and then we ship. You see the way the shipping agents, they put everything into your box, they put it on a ship or in a container, and they put it on a ship. That is the same thing. Okay. We also bundle softwares and we are able to run them. Then they came up with ECS. Then they were like, okay, all right, these two people usually what? Manage the infrastructure. Let's come up with something that people will not manage the infrastructure. We will take care of it for them. Now, if you hear serverless, it does not mean there is no server. Please take it from me today that if you hear the word serverless, serverless does not mean there is no server involved. What it means is that there is a server, but somebody is taking care of the server for you. Okay, so it's like having what is it called? Maybe having a house, but you are saying, oh, there is no stress in this house. Why? Because you have people taking care of the house. They weed the house, they clean the house, they cook, they do stuff. So you are saying no stress because literally you are not the one doing it. That is what is happening. When you hear somebody say serverless, it means they have offloaded the server responsibility for somebody like AWS, like Google, like Azure, and the rest. Okay. Now, that is the same thing here. So they come up with a serverless compute called AWS Lambda. Now, because the containerization to people were running it on EC2, which is through the virtualization on this EC2, they were like, okay, why not we create something also that we can run the containerization also on it without the people having to take care of the underlying infrastructure. Then they came up with serverless containerization also. Then they brought Fargate. So what is Fargate? Come and run your container services without what? Taking care of the server. And they call it serverless. So please and please, today take it from me that when you go for interviews, they can trick you. They will ask you, what is serverless? Please don't go and say serverless is something that's, a computer that don't have server or a system without server. No, it has server, just that the responsibility has been offloaded to a third party or the provider. Simple. Now, whilst AWS was doing all of this, they also thought of it that, okay, why not we create our own processor? Well, let's create our own processor. In 2008, they came up with a processor called Graviton. Okay, so AWS has its own processor, just like you have Intel, you have Core Celeron, and the rest. AWS also have their own processor called Graviton. As at now, AWS has other one that was also created in 2021, which is what we call AWS Inferential and Terranium processors. Okay, they are used for machine learning and other specialization processing. Any question? Any question? All right, so that has been the origin of compute services. AWS services that we are going to look at in this model, we will look at EC2. We will also look at EBS, Elastic Block Store. We will look at the hard drive that is behind EC2. Then we will look at compute or serverless compute service, another one which is what is called AWS Lambda. So what should the team consider when deploying new and existing servers to Amazon EC2? What should we consider? Well, if you are deploying a server, what do you have to consider? Now, we should know that these servers that we are getting, they exist on a physical server. Okay, that are in a particular region. So we shouldn't think that, oh, we are getting a server which is in the cloud, it is in the space. Maybe God is control. No, it's not God. It is human being. It is just a technology that has been utilized and effectively. Okay. So you should know that physical servers host the EC2 instances in AWS regions around the world. Now, EC2 instance give you secure and resizable compute capacity in the cloud. You are able to tune it. Okay, so you can use T2 now and decide that, okay, few seconds, I want to use M4 large, I want to use C large, I want to use whatever class that you want to use. Okay, so you should also know that you can add or remove compute capacity to meet demand. You don't have to, unlike your on-prem. Now, if you go and buy something, that is all. Well, let's say you've gone to buy rice. You've gone home to prepare the rice. Then you go back to the shop owner where you bought the rice and tell them, oh, the rice is not sweet. So collect the rice and then give me the equivalency of the rice and give me the balance. You collect something in Ghana called koto, knock. They will give you knock. So we don't do that. Why? Because it is not done. On AWS say, hey, don't worry. Whatever you buy from us, whatever you take from us, you can bring it back and then come for your money. Or you can bring it back and save your money. That is all. You are not tied to anything. Okay. So that is it. Now, before we launch an instance, there are certain things that we should consider. All of these are factors, okay? We will look at the name and tags we want to give to the server. We will look at applications and then OS images. When we say images on AWS, we are talking about OS, operating system, okay? So applications and operating system. Once you see OS image, it's like Windows, like Linux. Okay, think of it that way. Then the instance type. Okay, what is the instance type? What is the size that you want to use, and all of those things. We also need a key pair. We SSH into the server. We need a key pair. Then we need network. You see, so this is the ENR. Okay, the Elastic Network Interface. We also need it because this is what will help us to connect the server to a network and give us security group. Without this, we cannot create security group. Okay, we also need a storage. Yeah, we need a storage to be able to create that. Then we need placement and tenancy. Now, when we say placement, there is a way to session our VPC, our service. Okay, so there is a way. Maybe we want it in a clustered manner, in a scattered, in a spread way. Yeah, we can also do it. Okay, then we can put a script. Now we've write a script this morning. We didn't write it from scratch, but we asked AI to write a script. The script that went on the server to say, hey there, this is coming from the public subnet was a script. Okay, and we also have a metadata. What is metadata? Metadata is the information of the instance. Okay, so when you hear the word metadata, metadata is a data of a data. So the data of the EC2 instance can also be classified as the metadata or any data of a data. You have a database. That database has a short note that tells people exactly what is inside that database. It is a metadata. So it is a data telling a data or telling people about a particular data or a data of a data. Simple as that. Any question? All right. So let's look at tags in EC2. Okay. We can use tag to filter out. Okay. Why is tagging very, very important? Tagging is very important. Now, I can go to US and be like, all captains should put their captain's band down. Why will certain group of people listen to me? Because of tagging. So tag is like an identification. Now, if I say all policemen in the UK, you should meet me exactly 1 p.m., they will all try to come. Everybody that has a tag and it shows that they are policemen, they will come. So tagging is very, very important. Okay. So when you are creating resource, that is EC2, you assign a name and to the resources. So remember, we give it private server, public server. You assign a name. You can also add some tags to it. Okay. So if we want to search that particular tag, we can go ahead, just like we do. All policemen should be available. We can also search using tag. We'll say, okay, tag that has the word DevOps, all of you, all resource that has the tag DevOps, all of you show up. Or maybe you have the word cloud, all of you show up. Yes, we can do, or maybe marketing or whatever. Okay. So more tags are better than fewer. Yes. So, well, so tags are like names and identification of a person. So if a person has a lot of name, maybe they call you Joseph, they call you Emmanuel, they call you Michael. But if somebody call Michael, you are responding. If somebody call Joseph, you are responding. In this context, if you are looking for a keyword and you miss one, you'll be able still to get the server. That is why they are telling you that more tags are better than fewer. Okay. So tags are case sensitive in a way that don't write Penti with small letters. Okay. And then go and look for Penti with big letters. No, it will throw you an error. Okay. So if it's small letters, then look for small letters because they are what? Case sensitive. Any question? So if you look here, look at what they are doing. So they are tagging, they are writing owner development 1, owner development 2, owner development 3. So they are just tagging these resources. Okay. Now, the owner can be like, okay, I want to delete all dev2 resources. And once they click on delete, it's going to delete all the dev2 servers. Any question? So tagging are very important. Then we have what we call Amazon machine images. And I said it is what? OS or yes, the operating system, just like Windows, just like Mac, just like Linux. Okay. So these are OS of the instance. Any question? Now, in the cloud, the OS contains even the volume. They are not just OS. They are not like, your normal on-prem where you run Windows and then that is all. No, when it comes to this side, they even contain the volume. They contain some launch permissions. Okay. If you don't have permissions, you can't use them. It's just like if you don't have a license, you can't use Windows. However, in Africa, most of them are using pirated. Okay. All right, we can also do some block device mapping. So we can do some nested thing on what is it called? The templates. Okay. We can do some pre-configured templates. We can ask it to map to a particular storage, to map to a particular stuff using those one. Now, what is the advantage of the AMI or of the OS? Repeatable something. It is repeatable. The OS that we use for server 1, we can use it for server 2, server 3, server 4. We can use the same thing. However, we can create one server, configure everything on it, and then create an AMI out of that server and use that AMI to deploy another service. Now, whatever that existed on this AMI will now be available on this service. Any question? Now, the other thing is reusability. Yes, OS. Think of OS. You're able to use the OS again and again and again and again. Okay. Recoverability. Yes, when it comes to this, because it even has what? Instant volume. You are able to recover resources that was embedded in the what AMI if you mix it. Any question? Any question? All right. So where do I get AMIs? Well, I'm going to show you, but we have some pre-built AMI, which is what you call them, what quick, is it quick AMIs or quick something AMIs? We will look at that. Okay. Then we have marketplace. Now, With a marketplace, you can decide that, okay, you are looking for enterprise like Fortinet, you are looking for Cisco, Sophos, and those people. Ubuntu people, organizations that are known by AWS. They vetted their AMIs. Yes, in case you want to buy EC or you want to provision EC2 and install what's a firewall on it, like Sophos firewall. AWS already has what? AMIs. That's the Sophos themselves has installed the firewall on it already. So you don't have to kind of go and start from scratch. If you use that AMI, you get all the Sophos installed on the machine once it is on. Any question. You can also create your own. You can, so just like you are seeing, this is a server running. They've created an AMI out of the server. Or you can build something called a golden image. Okay. You are building going to use image builder. Okay. AWS image builder. I promise that we will not go too deep, but let's look at something. I can't do everything theory. So let's look at image builder. All right, it is right here. Okay, so you can use image builder to build your own AMI from scratch. Okay, so image builder, because building of AMI is very, very complex. Image builder is there to simply help you to just be like, okay, I want to use Linux 2. I want to install this software on it. I want it to have this software, that software, this software, that software. You declare it, and then it creates the image for you. Any question? Any question? It is called image builder. Any question? Now, let's look at how to get AMIs also. So let's say this and say EC2. Now, let's scroll down until we see AMI. So look at AMI. Now, there is quick start AMI, which is what we are seeing right here. So let's go to AMI catalog. Okay, there is quick start AMI, which is what most of us have been using when you are trying to provision server. This one is for AWS that has been made available for you. It has been vetted and approved by AWS. Then we have my AMI. So your AMIs are AMIs that you yourself you have created. So you see, I have one called Gameli. I have one called Penti IAM user. Okay, so they are mostly AMIs that you yourself you have created. Okay, that is what you should take note. And then there is market AMIs. So like what I said, the Fortinet, FortiGate, okay, these are firewalls, okay, as you can see, these are generational firewalls, okay. So in case you want to deploy EC2, install this one on it. AWS already have them. They've made their firewall already available or their AMI already available. So think of it this way. If you go and buy a phone, once you start the phone, there are already made software applications, games that are installed on the phone from the manufacturer. That is what is happening. So you don't have to install those games from scratch again. That is what is happening here. Okay. So think of it this way, that they have installed what they want it to be installed already from the ground level. So once you deploy it on your server, it will have all the softwares installed, just like you buying a new phone. And there is a community AMI. AWS do not advise that you use community AMI. However, if you go ahead and use community AMI, you are using it at your own risk. That is community AMI. Now, it is published by anyone, so you can see it right here. Anyone can publish it. So what people do is that they can even put antivirus or virus on a particular AMI and deploy it here. Once you don't know, you go and take it, you use it to deploy your server. That's why they will hack your server. Simple as that. So AWS is telling people that, hey, do not be using community AMI because it has not been vetted and approved by AWS. However, people made it available, so you can also use it. Maybe you are practicing something and they've already done that. They will make the AMI available for you. Any question, any answer, any addition? Right, so let's go on. All right, so understanding instance type names. Okay, now everything from the generation to the instance type or to the instance size make the instance type. Now, when you see this name, okay, now the 7, the number you see here is the generation. So if it's 6, it's 6 generation. Now, the first letter you see is the series. And then the other ones you see that are attached to those numbers are what we call the options. So this one is having G. It's telling you that it is using the Graviton processor, the AWS Graviton processor that I showed you. Had it been, it is Intel, okay? it being a C, it's using a Celeron or say what there's some processor. So this N is telling you that more network, it has a lot of bigger network. Yes, of course, this C7 uses a lot of bigger network. If it's more G, then or more M, they are telling you more memory. Okay, or the system has more memory. Okay, so that is it. And then this is to illustrate how bigger the thing is. Is it micro? Is it milli? Is it micro? Is it large? Is it nano? And those kind of things. So this one is the size. Any question? Now everything together makes what we call the instance family. Is there any question? All right. So there are a lot of instance families. We are looking at general purpose. We are looking at M machines. We are looking at T machines. Okay. All of these are what are general purpose. We have memory optimized. Maybe we want more memory rather than anything. We don't need a lot of storage. We want more memory. Then we can go ahead and use the memory optimized servers. Okay. Then we have storage optimized. We also need more storage. We can use this. If you want more compute, we can go ahead and use more compute. So you can see the C is falling under the compute. Okay. So that is why you saw the graviton there. So it's telling you that more computation. Graviton, that is the AWS processor, is used for highly computing applications. Okay. Yeah. And we have accelerated computing. Yeah. So you are also doing some accelerated computing with some classes of their servers. And we also have high computing optimized or high computing PC. Okay. Yeah. These one too are used depending on what you are doing. Now, however, do not chew and pour these types of what? Of instances. Do not chew them. The general purpose, just know that there is something called general purpose, memory optimized, storage optimized, compute optimized, accelerated computing, HPC optimized, or HPC computing. Okay. Do not worry yourself and between R6, R9. No, do not chew all of this into your head. I tell you frankly that I do not know all of this in my head. You don't have to chew it. As time goes on, you just improve with time. Any question? Benefit of a newer instance type. Okay. Okay. Why do you think people are using fast cars nowadays? So let's leave cloud. Let's come to normal cars. I mean, we are all men. We like cars a lot. Why do you think people are using fast cars nowadays? Let me ask you a question. Why do you think? Hey, you people don't like fast cars.
No,
What?
because it's fast.
The performance.
Oh, it's for satisfaction anyway.
Some for show off, so everyone has
it's
their
just,
own reason why
it's
they're
just to
using it.
satisfy yourself. That's it.
Okay. All right. So you remember those days when, Africa used to use the wooden car? It would take them about 8 hours on a journey of about 40 kilometers. It would take them about 3 hours, 4 hours to journey only 40 kilometers journey. Why? Because the car does not move fast. The more it doesn't move fast, the more it burns fuel, the more it delays. So AWS is saying, okay, what is the benefit of using the newer generation? It improved the performance because the car was using like 2 hours, which now some cars can use just 15 to 10 minutes to journey, 40 kilometers journey, which these people were using what? 2 hours. So now, the more you use fast cars or the more you use newer versions of things, you improve the performance of it. Okay. So you are able to shorten the time. All right. Then cost efficiency. Yes. See, if you think that, oh, Ferrari is going to cost more than the olden wooden cars we were using in Africa. Yes, Ferrari will cost more. But the problem is you also buy a lot of fuel when you are using the wooden car. Okay. Because this wooden car, guys, give me a second, just a second. I'm coming. Yeah, sorry, I had a call. Okay, so you say that, okay, yeah, but the Ferrari is going to cost more. Yes, but 2 hours driving, imagine the petrol you will buy compared to 15 minutes driving, compared to the petrol that you will buy. Okay, so indirectly, it's more efficient because if you get there early, you're able to do what you are doing and then come back early. Okay, yeah, that is it. And then scalability. Yeah, we are able to scale based on the newer instances. Some of them are inbuilt elastic and they are able to scale automatically. Okay. All right. Well, we've talked about all these instance type. My question to you is that are we going to know the exact resources that we want to use or the exact server we want to use? No, we can't know. We are not machines. So AWS thought of it, and then they've made a service available called Compute Optimizer. Now, I'm not going to show you Compute Optimizer on the console due to time factor. So please get some time and then go and look at Compute Optimizer. Okay. Now, what Compute Optimizer does is that it scans your AWS infrastructure. It scans it. Okay. So it checks things like your CloudWatch metrics. It check things like your server usage and all those things. It uses machine learning, okay, ML. It uses machine learning, and it is able to infer that, oh, you need T3 with time, or it will tell you, okay, you need C4 large, okay, or you need M large. So it gives you recommendation. It's just like trusted advisor, but this one is advising you based on your compute usage. So if your compute is over provisioned, it will tell you, hey, you are using a bigger server, use this server to save cost. So you can use compute optimizer. Is there any question? All right, so there is a key pair, something on the concept here called key pair. A key pair is used to SSH onto your server. So you can see this is a server. This is an illustration of a server. Now, before you SSH on any server, you cannot just leave your laptop. I'm trying to use a terminology. It's not coming. Let me clean it. Yeah, so you can't just use your local machine. Yes, of course, your local machine without a key to just hit any server. No, you'll be blocked. As you can see here, you'll be blocked because you need a key. Okay, now this key is called key pair. When you hear a pair, it means there are two: pair of source, pair of battery, pair of this, pair of that, pair of this. There are two of them. Now, what AWS gives to you, the owner or the customer, is called the private key, and AWS keep what we call the public key. So if you try to SSH into your server, AWS check your key against their own. If it's correct, they allow you to SSH. If it's not correct, then they block you from SSHing. That is why if you misplace your key, you can't SSH into your server. There is also something called tenancy. Now, tenancy is how we are kind of grouping servers. Okay. How do we group servers? There are three ways of grouping what servers at the moment. Okay. Now, we have the shared tenancy. The shared tenancy is what you are using the hardware, okay, the hardware that your server is provisioned on. You are sharing it with someone. So just like what we did, we provision a server. Now that server we've provisioned is using what we call the shared tenancy. So the physical host, AWS can also give somebody from China, somebody from Iraq, somebody from somewhere. They can also give them a server portion on there. Okay. Now, when it comes to dedicated instance, this side, once we delete it, AWS will go ahead and apportion it to another person who wants a server. But when we talk about dedicated instance, the physical server that is given to you, the one they have session for you, okay? So they have session 1 and 2 for you. You tell AWS that, okay, these two servers you have given me, I want to dedicate it. I want you to dedicate it to only me, only me. Don't give it to anybody again. Just dedicate that service to only me. Now, however, don't forget that also the underlying resources are shared with other people. Just that the service that has been dedicated to you will be used by only you. Even if you are not using them, it has been dedicated to you. AWS will not reapportion them to anybody. Any question? Any question? Any question? All right. So I guess silence means consent. You all understand now. Give me a second. Let me test someone. Sorry. All right. So since there are no questions, then we have something called dedicated host. Once you hear dedicated host, we are talking about the physical server. You know, the physical server that exists at AWS is the one that they put the hypervisor on it, and it is able to session. Now, some companies buy that physical server. Okay, they tell AWS that, okay, AWS, you know what? The host that is running, and you use it to provision the resource for me. Don't let me share it with anyone. I want to use the server alone. We call that dedicated host. So please know that dedicated instance is what, when you are isolating what your kind of this hardware that, or this software session that has been given to you, it is for you. Dedicated instance, you are dedicating the instance to you alone. But in this case, dedicated host, we are isolating the entire hardware. You see, the hardware is right here, the physical hardware. We are taking, we say, oh, we want the hardware, we want to take it, and that is the most expensive one. As you can see, this one is small, this one too is 2x, this one is a lot of money. Yes, because that is the most expensive one. In case a question comes and they're asking you to iterate the one that is cheaper or most affordable, please go for this. After this, then this is the 2, then this is the 3rd one, this is the most expensive. Any question? All right, so placement groups and use cases. Well, so there is something called AWS placement group. Why is it important? You see, the way we provision servers, you can say that, okay, I want my server to be closer to each other. So look here. So you can say, yes. So you can say that, okay, this, oh, that is not a server, sorry. You can say that, okay, this my server. If I get another one, provision it here. Maybe they have another one somewhere. You don't want them to come and provision here. They should provision it right here in the next second. Give it to me here. Get another one too here. Don't come and give it to me. That kind of thing. Now, you have the option to do all of that. Okay. So we call them placement. Let me see if we can quickly get something. Let's say EC2. Say launch. Without these. All right, so let's go to advanced. Yes, that is it right here. So placement group is right here, okay? So we can say, okay, what is the placement group that we are creating? We do not have any placement group because we haven't created yet. So we can go ahead, we will say, oh, we want to create a placement group. What do we want to give it to the name? Maybe we want kind of, create a placement group. Then we can go ahead. So look at the strategy. We can use spread, partition, precision time, specify another strategy, cluster. So there are a lot of them. Now, how are they working? They are working in this context. Okay, because sometimes we want servers that are closer to each other. So you can select a specific placement group that you want. Okay, when do you need to use this? When you want what? Low network latency. Why? Because this one is closer to this one. Because they will not have to go through length conversation before. Somebody too wants spread. Why do they want spread? For high availability, for fault tolerance, HA, high availability. They want spread. So the spread means, okay, create one here, come and create one there. That is why you are seeing it here. You see, this is one here, this is one here, this is one here, this is one. They are scattered. They are not at the same place. Baby. Somebody to say, I want spread. Okay. Now, they also use spread for like medical health records where they are pulling record from different angle. So theater is pulling from operation is pulling from cardiovascular center is pulling from ICU is pulling from what is it called, children's, this one hospital, the what do they call the children's own?
Pediatrics.
Oh, I see. All right, so they are pulling from different angle. Okay, so they will say, oh, we don't want you to center it at one place because why? There will be a delay. But we are pulling from different angles. So scatter it for us so that we are able to have fault tolerant or critical architecture. So that even if this one is off or this entire infrastructure is off, it will not affect any of our resources. Okay. Then we also have partition. Okay. So Partition also, we can go ahead. We will be like, okay, we do not want to kind of cause a collation. Okay. So what are we going to do? Create one here for us, one server here. Come here, create one for us. Come here, create one for us. On each of every one of them, create one for us. Okay. They are also looking for what? Large distributed and replicated workload. Okay. They don't want the workload to be on one, so they are distributing. So placement group, there are a lot of them. Please take some time to go through placement group to understand this better. Okay. Because for time being, I will not really practicalize this with you. We have user data. Okay, have you thought of it? When we want to run a script on AWS, there are two ways. Either we create the server, we SSH to the server, and we run it. What happens if we don't want to do that, but we want to get a script like what we did here? We just want to get a script and say, maybe we copy this one, and then we come here. Or when we are about to create a server, where is it? What is happening? Right, let me go to instances. Oh, I think one is here. Yeah, it's here. So see, there's user data right here. We don't want to create the server before we will say, okay, take this and run it for us. So we can give it a script to run. Okay, when we paste this here, when the server is provisioned, it's going to run all the scripts for us. And what is it going to say? It's going to deploy something on the website. Now we can say, can decide to put something here, we say. User data, right? So let me go here. Yeah, there you go. So that is it. Now, one disadvantage about user data is that it runs only once when the server is created. So if it doesn't run, we can edit it unless we SSH onto the server. So please take note that when you are testing your user data, you have to make sure that it is something that is working before you give it to it. Okay. So I'm going to say create so that we see if it works indeed. Yeah, I'm going to say proceed without a key pair because I'm not going to SSH and say launch instance. There you go. All right, so let's give it time to provision. So that is all. So depending on what you are using, now you see they are using YAM here. Somebody will say, oh, what is YAM? Please, it's not YAM. Okay. Now it's a package manager. We use it on Amazon Linux too. If it was to be Ubuntu, you see apt, APT. You see APT here instead of YAM. So APT. Okay. They are just calling a service that updates, they're updating the system and then installing HTTPD. HTTPD is what deploy the website on there. Now, because I'm not teaching you all of these today, we will take some time and go through them one by one, but get to know that there is a user data. Now, if you are a software developer, you understand this metadata better. Now, what happens if we want to use an environmental variable? We create the server. We, as a software developer, we want to kind of call the server name to say something, but we don't know the name of the server. We just give it a random name that Penti server, Penti this, but that is not the actual name of the server. The actual name of the server is hidden in its what? Metadata, the data of the data. So we can pull the metadata using some of these commands and then look at the metadata, okay? Or look at the resources that are associated with the metadata. There you go again. Please, I'll give you some homework. Go and practicalize metadata. If you have any problem, come to me. But this is the command. They are tokenizing this. So there was an older version that you could have done curl, and then you give it the this command, that is this, and then latest API is just going to pull. But of late, AWS is like, okay, it is against the security breach. So let's cut that. Then they implemented this tokenization one. Okay. So follow this same step and then try to see if you can work on metadata. Due to time, I'm not going to work on metadata. But when you are using metadata, we can pull all of this information Okay, we can pull instance ID, MAC ID, local host name. We can pull IPv4 address. We can pull local host name, IPv4, and all of those things. We can pull all these informations. They are all hidden in the metadata. So the metadata is like information of the server. Okay, I have the information of the server. If you want to ask the server's name, come and ask me. The metadata. I have the information. The server does not even know its name because its name is with another person called what? Instance metadata. Any question? Any question? All right, so we've looked at what we will do to provision a server. Now, what is the volume type that we will attach to these instances? We are going to look at it. Now, let's say we want to get a server, which is called instance A. Now, this instance A, we need a storage where it will install the AMI. Okay. Now, the AMI can only be installed on a storage that we call EBS, Elastic Block Store. Think of Elastic Block Store as a hard disk, the hard disk that is currently in your laptop. Okay, so that is how EBS is. EBS is 1:1 laptop, 1:1, just like your hardware in your laptop. Somebody cannot connect to that hardware because your hardware is 1:1 laptop, 1:1. You can't say one laptop should be used by two. I mean, one hardware should be used by two laptops, unless it's an external hardware and you bridge it and you say, okay, connect to this side. Let me connect to this side. But the actual one that lives in the computer, you can't connect two machines to it. Any question? However, there are some laptops that use two servers. Did I say two servers? Two storages, two EBS. Okay, so let's go and practicalize this. We will also not waste time on this. So look at what is going to happen. We are going to say, all right, first of all, let's open this to see if indeed our user data will work. And then we will say instances. All right, we will say create another instance. What is happening? Yeah, it's the delay again. Well, let's come to storage configuration. Now, look here. Look here. If we leave it, okay, it's going to kind of use this one. So storage configuration is using 8. And it's telling you that, hey, root volume. Root volume means this is why I want to put the AMI. The AMI, which is the OS, I want to put it here. However, I can say add more volume. So look at it. Add more volume. Add more volume. Add more volume. So I can add a lot of volume to one server. However, the root volume is always constant. The root volume is where the OS is going to live. Okay. So EBS is called Elastic Block Store. As you can see the name, you see EBS volume, EBS volume, EBS volume, EBS volume. There are even types of EBS. Okay. There are types of EBS volume. There is code, there is SSD, there is HDD, there is magnetic standard, and all of those things. Okay. But at the level, just know that there is code, there is SSD, or HDD and SSD. Okay. Which I think all of you should know by now. Right. So this is it. We have the primary one, which is the root one. This is where the OS is installed, as I showed you. Okay. Now let's go back to the console to look if our server is indeed ready. Where is this one? What is the other one that we were? Yeah, I think there you go. It's right here. All right, it's going to listen on port HTTPS. So let's just clean the X. Let's say HTTP. So there you go. Hey there, this is from a user data. Okay, so that is it. We can also practicalize user data. Had it been we want to deploy actual website using the user data, yes, of course, we can pull it from Git and let it do some zipping and unzipping, and we put it on there. It's going to also deploy it on here for us. Any question? Any question? Any question? All right. So then let's go on. Since there are no any other question. Right, so we can add more what is it called, EBS volume to one server. Okay, we can attach one or more EBS volume to a single instance. That is what I showed you. You can move EBS volume between EC2 instances as needed. Yes, you can move them. So you can deassociate the secondary one, attach it to another server elsewhere. Okay, but get to know that the primary one will always remains constant, because who delete primary now? Hey, you see, I've forgotten that I'm teaching international class. I'm speaking the local dialect, thinking all of you understand. So if you delete if you delete the primary one, they wouldn't get anywhere to install the OS, that is the AMI on it. Okay, so that is it. Now, EBS volume type. This is what we were talking about. I've already showed you that there are two major types of EBS. Okay, so the major ones are SDD and HDD, just like you can see them right here. Okay, HDD and SDD. But there are types of the SDD, which is what GP2, GP3, IO1, and what IO2 block express. Okay, then we have the mechanical one, which is what called HDD back volume. We have ST1 and SCI one. Okay, so this one, the olden days where something will be clicking, you'll be hearing, I mean, I don't know if some of you are using the laptop that is using the HDD, but you'll be hearing some fan rotating. Yes, so when you are using that laptop, this is the SDD is just like memory chip. It doesn't make any noise, no noise. It is the smoothest HDD, I mean the hard drive we've ever had. Okay, so that is it. That is the major one. Any question? Now, somebody is going to, I'll say, what is GP2? What is GP3? It's just the types, okay? Because AWS keep on making more advanced storages. Now, this was the old one, and they made a new one, okay? The funny part of it is that, please, when they are asking you a question and they tell you to choose the most cost-effective or most cost-efficient what? Storage between between GP2 and GP3. Now, which one do you think will cost more? So let me ask you, between GP2 and GP3. Okay, let's look at this. All right, go on. So go on.
It's going to say maybe GP3 since it's the more recent one.
All right. So you know what AWS does? They are so tricky to the extent that, think of it like Apple. Apple has made iPhone 17, which is the current one, right? Now think of it that 17 is cheaper than 16. Which one will everybody be buying?
17, the cheaper one.
Good. So in this context, this one is rather expensive than this one. Because AWS, when they bring a new technology, they want everybody to stop using the old one and come and use the new one. So they make the new one rather cheaper and make the old one expensive. So if a question is asked and they are delegating between these two, please go for this one to be the the cheaper one over this one. Okay.
Is that always the same for all services?
Not all services, but majority of the services, that is what AWS does. Now, you remember when they said the benefit of using newer instance, they said improve performance and all those things, speed, and yes. So this is it. They are saying that because this one, the speed of this one is higher than this one, so this one delays in calculations in computing, but this one goes faster. So they are charging this one less and this one higher. Okay. Not all the services, by majority. That is the whole idea.
Okay.
All right. So let's go on. This is EBS characteristics. So please, you can spend some time when I share this with you. You can spend some time to go through them. This is using their bursting throughputs and then their terabytes and all of those things. I'm not going to waste time to explain all of this, okay, because you don't need to have a higher level overview of it. This is just giving you a generic idea of all those storage and how they function, okay. Now, we have two types of storage, not even two, a lot of storage that we can hook it up to our instance. But the two most talked one that we are going to look at today is one, the EBS, and then what is it called? And then instance store. Now, what is the difference between instance store and then EBS. Think of it this way. Now, if you put money outside, okay, you go outside on the compound or maybe outside and you put money on the floor, it is not for you again because somebody will take it. Somebody will literally take it. But then if you have money at home, it is secured, it is persistent, it is always there until a thief breaks in. Now, when we talk about EBS persists data. It keeps the data forever and ever until you yourself, you decide to delete it. When we talk about instant store does not behave like that. What does it do? It is a temporal. So look here, non-persistent means it is temporal. Now, if you don't hear this word, non-persistent, temporal, you hear words like ephemeral. One, ephemeral means it is non-persistent. So you hear that word, ephemeral, non-persistent, or temporal. These two words, this is what they will try to trick you when they ask you a question about instant store. Now, it is a volume that is non-persistent. If it is attached to a server, once I stop and start the server, volume is gone. Everything on the volume, I'll lose all the data. So if I stop and start the server, I lose the data. I stop and start the server, I lose the data. Just like the IP address that we were given. I start and stop the server, I lose the IP. I start and stop the server, I lose the IP. I stop and start the server, I lose that. That is the same thing. Now with this one, you see, it is also 1:1. Look at it carefully. It is 1:1. You can be like, oh, I want to assign this server. I want to kind of assign it to another server elsewhere. No, it is 1:1. Now, why? Because they are physically attached to the host which you exist on. So if your host is host 1, they will attach it. The AWS will physically, those of you that have worked at the data center, they will physically attach the instance store to the host machine. So you can't remove it and add it to another one because maybe that server you want to add it to it is not on the physical host. That is why they don't allow it to be attached or to be reassociated to another instance. Now look at what is happening here. Stopping, you see, it is stopping it. And then the data that is right here, look at what is happening. We had the data here, which was a video. Now it is stopped. Look at it. Data is gone here. Data is also gone here. It's gone. That is all. So once we start and stop the server, we lose it. Once we start and stop the server, we lose it. Okay. So please take notes that it doesn't support what? Snapshot. Snapshot in the context that you can't take what? A copy of the data on there. So they are mostly used by companies that do not want to save the data. Maybe they want to run some kind of, think of it like game. They just want to see who will be the top winner. After playing the game online, they delete your data. Nobody wants your data again. Okay, yeah. So they are used for companies that can recreate the data on and on and on and on, and they don't want to kind of keep the data. Any question again? Right. What will constitute to the pricing of AWS EC2? Well, we have on demand. What is on demand? Okay, if I get it, I mean, if I want it, I get it. Okay. And I get it. When I don't need it, I just let go of it. Now, think of it this way. If you need to rent, maybe you don't have a car, you need to rent a car, you go get a car. If you don't need the car, you go and give it to them, you pay them the money. That is all. The more it is with you, the more you pay. Now, what happens? For you, you don't have a car, but you don't rent a car, but you are trying to beat the system. Okay, so you went to a car dealership and told them that, hey, maybe I'm going for a holiday in France. I will spend 1 year or 3 years. Please take note that it is not 2 years. There is nothing like 2 years. It is only 1 year or 3 years. I do not want to come and rent the car on demand when I need it. But what do I want to do? Give me the car. I want to use it for 1 year or 3 years that I'll be in France. When I'm going back to my home country, I'll give you the car. Now, and the dealer will be like, okay, oh, because you are renting it for a whole year, we will give you what? Savings plan. So if we calculate the entire amount, maybe it's going to be $20,000. But because you are going to pay us, what I'll do is that, okay, instead of $20,000 for the whole 3 years or 1 year, pay $10,000. Okay, so you have what? You have saved, you have made money. Now, savings plan can be done for only 1 year or 3 years. Am I treating this again? Please take note. 1 year or 3 years. But there is a committed something. You need to commit that you want to use that thing for 1 year. Now, if they want to if they don't use savings, they'll use the word reserved. Okay, reserved and saving plan, you can reserve for 1 year, you can save plan also for 3 years. Now, what is the difference between savings and reserved? For reserved instances, they are for instance alone. But when you are using savings plan, they work for Lambda, they work for Fargate, they work for most of the compute services. That is why people even like savings plan instead of the reserved instances. So reserved instances too, you can reserve for 1 year or 3 years, which is similar to this one. But there is what? There is a committed flexible access. There is a committed. There should be a commit to something before they give you that kind of thing. Either you are reserving, either you are using savings plan. Any question? All right, we have limited time. I don't know how many slides we are left with, but I think we have limited time. Right. Okay, is there anything? All right, so let's look at sports instances. What is sports instances? For sports instances, we have a company. Now, this company has a bigger server. Now, the server is not being used. It's not every day that they use the server. They can sell that spot to AWS and be like, okay, let people come and bid. When we say bidding, okay, Atta, bring your money. Dennis, bring your money. Gregory, bring your money. Said, bring your money. Let's bid. This is a car. Whose money will be bigger? The person will buy the car. So you hear them, oh, I'll give $10,000. I'll give $15,000. I'll give $20,000. At the end of the day, they give it to the highest bidder. That is bidding strategy or bidding marketing strategy. Now, the highest bidder gets the server in this contest, which is the sports instance. The disadvantage of this is that AWS can take the server from you. They just need 2 minutes to tell you that, hey, we are taking the server from you. After that 2 minutes, they will delete the server. You will not even get access to your resource. You will not get anything on the server. So they are mostly used by people that can recreate their workload. So think of it like an analytical company. They have the data on S3, but they pull it to the server just to run some analytics. After running the analytics, even if AWS take it from them or they delete it, they don't care. Okay, so sports instance are bidding. Okay, they give access to biddable resources. Now, this is talking about savings plan types. We are talking about compute savings plan and then instant savings plan. So just like I was saying, savings plan goes a way beyond just reservation, because it concatenates a lot of the compute services. I'm not going into now. This is the instance type, which I've already explained all of this, which is the sports instance. What did I say? So you go and bid. Okay, you go and bid, and then that one, after bidding, they give it to you. It is the most cheapest one. It is cheap. Like, they can give you a very big server. You can be paying like $7 per hour, depending if you are the highest bidder. Maybe the rest are saying they will pay $5. If you pay the 7, they will give it to you. Okay, but if somebody come and pay 8, somebody come out to bid you, they will take 2 minutes just to clear you from the server and give it to that person. So sports instances are used. They are like gambling. Okay, so please take note of that. Now, use cases for sports. So look at it. They are using media rendering. Maybe they just want to kind of go into some analytical views. They just want to convert some videos. They want to run some web services and then check something or maybe do some testing, or even run some big data analytics. So they want to run some analytics to see what is happening. Okay, what is happening on our data? Once the data is even lost, they can still replicate the data maybe in S3 or something. Okay. All right, you can also combine purchasing options. So you can combine on demand, you can combine sports, you can combine savings, you can combine savings also, depending on how much you are paying. Any question? How many minutes are we left with? Should we do Lambda before we close? I feel like let's finish with compute and close.
Yeah, that's right.
All right. Okay. So, all right. So let's look at Lambda. Now we are talking about serverless compute, just like I said. When it comes to compute, okay, actual servers, we take care of the servers, we take care of our code. But when it comes to serverless, they take the server from us. So look at that. We are only focusing on our code. We don't take care of the server and all of those things because we only write the code and bring it. And AWS is going to take care of the server for us. Now, one of the service that you can talk about so far as serverless is concerned is AWS Lambda. Now, Lambda is a serverless compute on AWS that can be used to run a lot of scripts. Now, it supports a lot of programming language such as Node.js, Python, Go, PowerShell, Ruby, and more. Okay. Now, the disadvantage of Lambda is that it has a runtime of only up to 15 minutes. If you have an application that will run consistently for more than 15 minutes, Lambda is not the best. Any question? So you have an application that will run for more than 15 minutes. Maybe application will run for an hour, 2 hours, 1 hour. Please, Lambda is not the best. Now, Lambda is an event-driven architecture. It can be, what is it called? A function can run based on an invocation. An invocation in the context that, okay, there is a cane at your father's home. Your father will never take the cane if you haven't done anything wrong. That is how Lambda is. Lambda can look at some specific thing and be like, okay, you will set it and be like, okay, Lambda, if this happens, run this or do this. Maybe if somebody provision EC2, which is below T3, go and delete it. Lambda can be waiting until someone provisions T3. Lambda will not run. And if anybody goes ahead to provision T3, Lambda is an event source, so it will just go ahead and then they invoke it because they have created the event, which is the event source. Maybe don't create T3, they've created T3. So invocation will hit Lambda, and then Lambda will what? It will give it a response, and then it will go and terminate the services. Any question? But it's terminating that based on the code that you have written, okay? So it's not just doing that on its own. It's terminating that based on the code that you have written. And it also supports memory of up to 10 GB, okay? Memory of up to 10 GB. So it cannot go up beyond 10 GB. Please take note that when you are having something that is more. Now, Lambda can be hooked or it can kind of do something based on a lot of things, based on CloudWatch metrics. It can do something based on CloudFormation. It can do something based on SQS. Okay, it can do something. Let's say S3, something falls into S3, a database, it can do something. DynamoDB, it can do something. If somebody tries to write to your database, config, it can do something. Event bridge, it can do something. Step function, it can do. So all of these services, Lambda can iterate Lambda to do a specific function. Okay. All right, what is the use cases for Lambda? We can use it for web application, backend, data processing. Okay, we have resource in S3. Whenever the resource or somebody uploads something into S3, Lambda, go and take, let's say it's a picture, go and take the picture and then turn it into thumbnail, or take the picture and then turn it into PDF, turn the picture or turn it into JPEG, into PNG. Okay, so yes, of course, we can do that. Okay, we can also use it for AI assistant depending on what we are using. Amazon Alexa, so you know Amazon Lex, where you say Alexa, do this, Alexa, do that. Yes, of course, you can also hit a Lambda using all of this. You can even use it for automation, where you configure it that, okay, if anybody creates a server and the server is T2, go and put it off. What have you done? Automate the process. And it's just going to do it without you intervening, okay? Somebody creates a server, it will go ahead, terminate the server, go ahead, terminate the server, go ahead, terminate the server, thereby leading to what? Automation. Any question? All right, we are done with this. So let's look at what we have done so far. What are the compute services that are available? Well, we have some EC2, we have some containerization, we also even have some processes on there. So what should the team consider when deploying a new existing server to Amazon EC2? Well, they should make sure that they are using a newer server, okay? So we look at things like cost and other factors. So how do you know which volume type to attach to your EC2 instance? If you want it to be temporal, you want a consistent storage, then you go ahead with EBS. If you are looking for something that is temporal, then you use instant store, okay? So you can use instant store because you want something that is temporal. How can we optimize cost for compute resources? Yes, so we can optimize compute cost by also running the newer version of instances to do the work faster instead of running the older ones where it will take some time to do the same work that the newer ones are doing at faster rate. Okay, where can we start with serverless? Well, start with Lambda. Lambda is one of the powerful serverless service. All right, so what did we do? We look at compute services, we look at EC2, we look at storage. We've also looked at EC2 pricing option. We've looked at Lambda. Is there anything that we have to look at? Let's look at some knowledge check. What statements are true about Amazon machine images? Select 2, AMI. Which of these statements are true? Let's do this quickly and close, okay? We are 2 minutes behind, so let's do this quickly and close. AMI, OS. So think of it like your OS, okay? Oh, people are lost. Anyway, Gregory, are you also,
D.
all right.
D is 1.
Okay, D is 1.
And B.
And B. All right. Why is it not the rest? So look at it. AMIs can specify the subnet for launch. No, AMIs do not specify. They do not specify that, right?
Multiple instances.
All right. So AMIs can only be obtained from AWS Marketplace. That is a lie. We can even create our own custom AMI. Okay. So it is not correct. AMIs can only be used by users within a single node. So AMI is made available if it's on the market, it's available. If it's a quick start, it's available for everyone. Okay. So yes, of course, we are leaving it with D and B, as you can see. Now, in the instance type name, M8G 2x large, which aspect of the name indicates the generation? Which aspect of the name indicates the generation? I told you that when you see I3, when you see I3, what does it mean? Third generation. When you see I7, it means 7th generation. If you see I10, it means 10th generation. So if you are seeing M8G, which one is telling you about the generation?
8. D.
Number 8. Correct. So the 8 is telling you about the generation, as you can see it right here. Okay. Now, which statements are true regarding Lambda? Okay. Regarding Lambda, let's look at it. Functions are currently only supported in Python. That is a lie. It supports more than Python. All right. So yeah, go ahead. I don't know why I'm doing the answer.
D is 1. D is 1.
Okay. So you said D is 1, and what is 1?
Then functions can be allocated up to 10 GB of memory.
Which one?
So
Which
C.
one? Which one?
C.
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 All right.
I'll go for B. You are responsible for that. No, it's
No,
serverless.
no.
It's serverless. So not B.
Yeah.
That B, I'm not sure that B can be one of the answers.
You see,
yeah, it's wrong. It's serverless.
Yes, Lambda is serverless. So you don't take care of the underlying infrastructure. So functions can be written only in Python. It supports Node.js and the rest. Now, function requires security group. That is a lie. It only need a role. Okay. A function need a role to run. So it does not require security group. So 15 minutes, yeah, maximum of 15-minute runtime. That is correct. And it supports the memory up to 10 GB. That is also correct, as you can see. All right, that is all for today. Any question before I close officially? Is there any question for me? All right, so I'm going to upload this and then expose the directory you all have access to. That is exactly what we will be using until the end of the program. So make sure that you have access to the directory, and then I'm going to add the slides and add the recorded videos as well for today's class. Is there any other thing before I leave? All right. So enjoy the rest of your time. Please get some time, go over the slides, practice, do something, get a server, provision a server, go ahead and do something. Okay. And then I promise you that by the next few months, yeah, you can start applying for a job.
Thank you.
All right. Thank you.
Thank you so much.
Yeah.
All the best. Thank you. Ciao, 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 ciao.